even die camera's aan het instellen op de juiste ligt.
kijk.
De linker. Als je aan het doen als het goed is. Zie je niet? Naar welk praatje kijk jij het meeste uit vandaag?
Ja, ik vind het allemaal interessant natuurlijk. Maar, ja, ik laat me benieuwen.
Gewoon open-minded.
Ja, precies. Ja, weet het. Als je de talks voorbij ziet komen, dan zie je genoeg interessante dingen.
Ja.
Dus dat, de afwisseling tussen technisch en non-technisch.
Ja.
Ja, ik zat laatst nog jouw talk te kijken. Ik was natuurlijk bezig met het lijstje van de oude presentaties, maar dat was ook wel weer leuk om te zien.
Ja, toch.
Daar ben ik ook helemaal klaar voor verder.
Dat is voor ons niet meer dan routine.
Nee, dat
is event is leuk en de mensen zijn leuk, waardoor het voor ons extra leuk is om hier te zijn. Werktechnisch is het gewoon een routine.
Ja, precies. Hoeveel events doen jullie?
Op jaarbasis? Die wij zelf doen of die wij als bedrijf doen?
Oh, daar zit ook nog.
Daar zit ook nog waarschijnlijk.
Oké.
Als bedrijf doen we er gemiddeld wel elke dag 2, 3. Maar wij als persoon, ik ben echt de luxe poes. Want ik doe alleen de dingen die ik echt leuk vind. Want ja, ik heb gewoon die kleine nu thuis. Dus daardoor...
En dan stopt het.
Midden? Okay. Where are you going?
Bovenin.
Daar zit je een beetje schuin. Dat is wel nicer, denk ik.
Ja, dankjewel.
Hi.
Ik microfoon, близко, можно будет вот.
Nikker, waar is de klikker? Ja, Nick had hem.
Maar je mag gerust een geld pakken. Daar is Nick. Is daar Nikker met de klikker?
Nikker, Nick.
Ik heb die ontiegelijk lange benen. Ja, er kwam nog een...
So good morning, everyone. Thanks for being here and finding your way through traffic. Perfect. Hands up for all of you for making it here on time. Now, obviously, as you can see from the concentration of t-shirts on the floor here, there is no technical issue. But yeah, when trying to do just the final thing to the laptop, something got unplugged, and now the color of the presentation on the screen is all wrong. So it is being worked on, no pressure. It is not orange. Oh, it is more. It shows a little more greenish than usual. Yeah, so it's very environmentally friendly. But, we'll be here soon. Yeah, the color is back. Yay! So again, good morning, everyone. Thanks for making it on time. Now, we should have made it on time as well, but a certain board member will remember this moment forever, I think. My name is Niels. I am the Vice President of NLNOG, and this morning I will introduce the speakers to you and maybe moderate the questions if necessary. The first speaker of the day is the chairman of NLNOG, Mr. Teun Vink, and he will give us some updates on the NLNOG Foundation. Take it away, Teun.
Yes, good morning, everyone. Okay, can we get the slides on the screen? Yes, excellent, thank you. Well, welcome, everybody. Good to see you all. Unfortunately, some people are still stuck in traffic, so I hope they will be here soon. But well, our program is packed, so we need to get started. Few things when we start. This is a professional event, and we'd like everyone to be the best they can be, so please be, well, nice to each other. In case anything happens that you don't like, please talk to either Natalie, who is over there, or Niels Bakker, who is currently downstairs at the entrance. It's the really tall guy. Can't miss him. And keep in mind, this is an event by techies, for techies. So, well, keep the sales level, well, to a minimum, I would say. Outside, no, if everyone agrees, it's fine, but this is not a sales event. This event is streamed on YouTube. All recordings will be available afterwards, so if you miss anything, if you'd like to share it with your co-workers, please do so. During the presentations, if you have any questions for the speakers, there are 2 microphones over there. For remote participants, you can ask questions either via IRC or Discord. If you do so, please start the line with Q double colon. So our well, moderators is maybe a nasty word, but the people watching the chats will know that this is a question. An event like this can't be possible without a huge amount of sponsors. And we were really lucky to have so many. Well, we do so much. We do the project like the NLNOG Ring, IRR Explorer, BGP Filter Guide. An event like this costs a lot of money, and we can do all of that for free. I'm going to name all of them. So here we go. M6, Arista, Bit, Correro, Duocast, FiberRing, Fusix, Genie Networks, i3d.net, KPN, LeaseWeb, LoanApp, Nexpertise, NLIX, Nokia, NTT Data, 10IT, OpenBSD, Amsterdam, yeah, I know, PowerDNS, Kwanzaa, Recorded Future, Ratten, Smart Optics, Solid Optics, Speak Up, SpeedIX, Telesol, and your hosting. Thank you all. And as you can see, we still don't have every letter in the alphabet covered, so if you represent one of them, please talk to us. We're happy to tell you more about sponsoring. Okay, what we did this year. Well, we had a New Year's drink on January the 24th in the Rechtbank in Utrecht, which was a lot of fun, a lot of familiar faces, also a lot of new people, which was very good to see. We had Lekker Weer NLNOG at BIT on June the 13th, about things you don't want to hear but need to know. We had very insightful talks by Octavia de Weert, Alex de Jode, Rudolf van den Berg, and we had a nice barbecue afterwards. We had some changes in the board, as Nathalie also mentioned on the mailing list. She has stepped down as chair of NLNOG. I have taken her place, and Cas has become the new secretary of NLNOG. Luckily, we onboarded a number of new sponsors, so welcome to those. And we finally built a new website. This was something we wanted to do for so long. And well, this is the moment we're going to launch it. And yeah, the only thing we need to do is, we're going to live demo this. We only need to restart the web server, so it's easy. Here we go. Okay. So there it is, our new website is live. And this is what it looks like. No more just people with a shopping bag in front of the Albert Heijn. Actually, we're explaining what our website, what our foundation is all about. And you can find a lot more information now. If you have suggestions, please contact us, because, we're always open to adding more information. Well, that was the part about the foundation. Now, I'm going to continue. Yeah, sorry. Okay, the other thing, there are some updates there as well. The number of ring nodes grew a little, by 22. The unique number of ASNs grew also a little, by 8, and 5 new organizations. This is the net result, so there are some joined, some left. Unfortunately, a number of countries decreased. We lost Georgia, Guam, Iceland, Taiwan, and Zimbabwe. In return, we got Serbia and Angola, so that's nice. And we're mostly at the point now that we really like new nodes in networks and in especially countries where we're not present yet. So if you have any presence and are able to offer ring nodes in, well, the countries that are colored gray here, please come talk to us, because we really would like them. It's really nice to have a broad view of the entire internet over the entire world. On the Looking Glass side, we also had some nice updates. Sebastian Koetsier, known as Freak on the IRC, unfortunately he's not here today, wrote code to offer an API to the Looking Glass, which is live for a few weeks now. This API offers access to all the information the Looking Glass can show you. Documentation can be found on GitHub and is linked from the Looking Glass website. Well, you see an example of a URL here where you can request a prefix from a specific node. And if you do that, you see something like this. A lot of information in a JSON format, and you can use that in your tooling any way you like. IRR Explorer also had some changes. Many stability fixes, maintenance releases like new dependencies, updated packages. We added support for Python 3.12, of course, sorry. We dropped 3.7. We fixed database lookups where national internet registries were preferred over regional internet registries, which is needed for countries like Brazil. We added support for route set objects. And we added an option so you can filter just the warnings and errors of IRR Explorer, so you don't have to see the informational messages. And it's a checkbox which you can tick. Well, very easy. Friendly reminder about our services. Our software, our projects, everything is built and maintained by volunteers. It's not a 24/7 NOC. It's not people who are always available to fix their things immediately. So keep that in mind. If you depend on those services for your continuity, you may want to reconsider your choices. Or may become a sponsor, and so we can buy a 24/7 NOC for this tooling. Sounds good as well. All our code is available on GitHub. Pull requests are welcome, of course. If you have problems with our software, if you have suggestions, if you have bugs, improvements, please report them. If you have new ideas on things NLNOG should be involved in, things we can do with the NLNOG ring or whatever, we're always open to hearing them. Of course, it's always the question, can we find people, time? Yeah, helping is also always very useful. But we're always open to suggestions. Use our services respectfully, please. Don't hammer them. The IR Explorer and Looking Glass are there for everyone, and it's not like it's just made for 1 or 2 people. We've seen a few incidents where people were really hammering the services to do their internal monitoring. If it becomes problematic, we take measures, and I don't want to do that. And if you like our services, please consider supporting NLNOG. Hosting services cost money. For some services, we need to buy some developer time to get them fixed. So yeah, support is always welcome. And that is my part of the presentation. I'm now handing it over to you, Niels. Please enjoy your day.
Yeah, my next bit is about a board member saying goodbye. Natalie is leaving the board of NLNOG. I know that you absolutely hate to be in the center of attention. So relax, this is going to take a while. I will dive into history too much, and I will reveal too many personal details. So no worries, you'll be fine, you'll be fine. So to go back, okay, that's great, thank you. Just to go back in history, to the beginning of history, it seems that we were on the same secondary school, the infamous Saarlands Lyceum, but we don't remember each other there at all. So there was nothing I could tell from that time that would involve Natalie. Then work. We could have been colleagues in the previous century already. I don't know how you got in UUNet, because my situation was like, when I decided that I would like to work for an ISP, I sent my resumes to Demon and to UUNet, and Demon called me 5 minutes later, and UUNet emailed me 5 weeks later. So I don't know how you got in that company, but nothing common there. It all started when you joined Demon, and that was when things got settled. Our common history started. And of course, I've looked back at emails that I exchanged with you. I find things about moving domain names. I mean, how complicated could things be in those days, man? You sent every now and then a list with adjectives and names of colleagues, and then you asked, can you match them for me, please? It's very interesting exercise. And of course, I was reminded by, to your famous karaoke show at Beat Radio. Not too many personal details, right? No. And I even found your original entry form into ColoClue, because that was also a life-changing experience, I'm sure. So I told you this is going to take a while, don't worry. But when it comes to NLNOG, As we know, the start of the official foundation is now over 10 years ago. And you and I were both part of the original gang registering NLNOG at the notary office. And in the years that followed, we both did our things in the board and helped organize many NLNOG events and other NLNOG activities. And at the same time, your career changes helped you build an enormous people network. You know people in the most unusual places and cultures. And this has helped NLNOG tremendously. So thank you for that. But when you, it's not that bad. When you really started to shine, Natalie, was after the small board reshuffle in 2019, when you became the NLNOG chairwoman. It was your contacts, near and far, that were indispensable. And the amounts of emails, calls, and texts that you put into NLNOG were literally uncountable. Your experience with events, as a visitor, but also as an organizer, far bigger than any other board members, helped us find the weak points in the event program planning very quickly. And in these last 2 weeks before this NLNOG day, you have even written a complete handbook on how to organize an NLNOG day. And the board will be enjoying your work forever. And now, you say goodbye to the NLNOG board. Of course, we know that you are not gone, and we will certainly keep seeing you at future events. And there is something that we have done to make your travel to future NLNOG events a little bit easier. And that is our small present from us to you. It seems to fit the bill for your personality and lifestyle. So thank you for all that you've done. And stay in touch. You can say something, yeah. Do you have cue cards? No?
Okay. I don't like speeches, and to be honest, the worst things of organizing an NLNOG as a chair the last years have been the nerves to stand there and do the opening and the closing. It's just not my hobby to be here in the center. I love working in the background and having contact with so many of you, with all our sponsors. I can share 10 anecdotes of everything that went gloriously wrong in the lead up to these events. Maybe one day I will. But yeah, for now I just want to thank my fellow board members, the ex-fellow board members that we worked with, all our sponsors and you for the support. Thanks.
Well, thank you, Natalie, for all that you've done. We will be very happy to see you again at future NLNOG events. There's not much more I can say about it. So, right, we get to the technical talks of the day. And exactly on schedule, yeah. My first introduction for the day is that of Rinse Kloek. Rinse has been regular at NLNOG meetings. He's told us everything about his adventures in the access world. Everything from fiber to the farm. That was one of the first, I think. And today he's here to tell us a little bit about an infamous protocol, DHCP. And to be more specific, migration of the, well, what can I say? ISC, DHCP, let's not put an adjective in front, to Kia. So, Rinse, the floor is yours.
Thank you for the introduction, Niels. Today I'm going to talk about the nicest protocol there is, DHCP. Somebody say DNS is the nicest one, but I think it all starts with DHCP. Without DHCP, you have no IP. Especially, I'm going to talk about the migration from ISC to KEA DHCP. What are the topics in the presentation? First of all, what is the reason Delta Fiber switched from ISC DHCP to KEA? I did this project for Delta Fiber to give some context. Then something about the unique features of KEA DHCP. Something about the whole migration process, how did we do that? And last but not least, something about monitoring and also an interesting case I will explain to you. The name KEA, they choose the name, KEA is a parrot that lives in New Zealand, known for his problem-solving techniques and adaptability. You see it in the picture. And also, they choose KEA because it's just a short name, so easy to remember. Why migrating to KEA DHCP? ISC DHCP, I looked it up. It's already 30 years old. The first code was committed in 1995, so it's pretty old. It's pretty mature, so it's very stable. Delta Fiber uses it for almost 20 years, I guess. But the code base is very old, so ISC did some investigation. They want to refactor the code, but after some investigation, they only thought the header files are useful, so maybe it's better to start all over again. Second thing is ISC DHCP has no modern API, so they had some API with OM API, but that's not so flexible. You can't reach it from outside, so no, it's not very useful. Next thing is that if you want to do changes, for example, adding subnets or adding host reservations, that's all in the config, and you need to do a reboot, so a reload of the daemon. So every change has downtime, and sometimes a reload of the daemon can take up to 5 minutes, and that's not something you want. And last but not least, ISC DHCP has no option to bind your lease to option 82. So the lease was always binded to the MAC address, so modem swaps were not so easy, and that's something that happens a lot if you are a service provider. Yeah, something about the architecture of KEA. The first thing is KEA has a nice database backend, so you have the option to store all your information, your variable information in a database. You can choose Postgres or MySQL. And the things that normally you do in a database are leases, host or subnets. Next thing is that KEA is the code base is very small. So if you want to have extra functionality, like the database backend, then you load plugins. So you can compare it with Apache. Apache has modules. In KEA, they call it hooks or plugins, but they function like a model, so you can extend your functionality by adding extra hooks or plugins. There are a lot of plugins available. Most are free. So as of KEA 3.0, I think all of them are free except the subnets and the access plugin. They are not free, but most of them are free. Then KEA has a very nice REST API. So they have up to 200 different API comments you can use. For example, updating a lease, adding subnets, removing subnets, config checks, reloads, everything you can imagine you can do via the API. On the right side, you see an example of how you add extra subnets. So it's all JSON-based. So if you're familiar with the REST API with JSON data, it's very easy to use. It is also like ISC, high availability is an option. So you can have active setup or active passive setup, and the two servers will check each other if they are live. And what they add is that they also check if their requests are coming in. So it's not only checking each other, but they also have a very smart mechanism to see if the other peer still gets requests and also can answer to the requests. And there's a lot of more. There's very good documentation. So everything you need to know is on the website. It's very extensive, so that helps you to do research and to see how you have to implement things you did in ISC, have to implement in KEA. Last but not least, they have a graphical dashboard called Stork. Stork is a separate project. They started, it's an open source project, and it's meant to run and to monitor all your DHCP instances. For example, if you have a lot of DHCP servers, you can have just a single page, a single view to hold your DHCP cluster, and that can be very helpful. Then something about how Delta Fiber does DHCP. On the left side, you see The client does DHCP requests. They go through the switch or the OLT. OLT does DHCP snooping. DHCP snooping means adding extra information in a request, for example, the unique client ID or the circuit ID where you are connected. And also IP source guard is done on that switch, so it knows what address is given to the client. So you can also do some source guard and do IP spoofing protection. It's very nice. And then at the router, the broadcast segment ends. So the router is the relay. So all the requests, broadcast requests, enter the router, and the router relays requests to the DHCP service on the right side. We have two servers, and at Delta Fiber we use the active setup. So both get a request and both can respond to the request. And they have some algorithm that they decide to what MAC address what server does respond. So they have some mechanism to determine that. At the bottom, you see how the process goes. You have to discover, the offer, the request, and acknowledge. And in the startup phase, the requests from the client are broadcast, so you need that relay to send it to the server. And that's also the reason that it's called the DORA protocol, because discover, offer, request, acknowledge. It's DORA. And also Peter told me there's also an open source project that is called DORA. So there was an open source project to build a new DHCP server, I think in Rust it was, and they called it DORA. So, yeah. Then one of the plugins that Delta Fiber uses the most or has the most benefit from is the Flex ID plugin. Like I told you, the old ISC had only the option to bind your lease to a MAC address. At a service provider, a MAC address can change because users can swap their device. But what you want as a service provider, if you have, for example, fixed IP address, you want to have always the same IP address to that same customer, and you don't want to have that bind to the MAC address, but bind it to another unique identifier. And with KEA Flex ID plugin, you can choose what you want as the identifier for the lease. In our case, we use the remote ID, and the remote ID is provisioned by the provider itself. So we have a unique remote ID, and in the case of Delta, that's the order ID or the service ID of the provider that's provisioned to the network, to the OLT. So with this plugin, we can always give the same IP address to the customer, regardless of what device he is connecting to to his connection at home. At the bottom, you see the old situation. In ISC, you have the MAC address that is filled in the client ID field, but in KEA, you can have some configuration that you can decide what you want to have as client ID. In our case, it's just the SP0, that's the unique code of the customer. Yeah, then another thing we did change by using KEA is that we extended the default lease time. We had a lease time of 30 minutes. Now, the 30 minutes is pretty low. The reason for that was, there were two reasons. One was that if you want to swap CPEs, sometimes the lease does not get deleted. And you had to wait for the lease to expire before you could connect a new device. So we decided to make it low. And there was also some bug in some Cisco router, I think 8 years ago, that they advised us to lower the lease timer. So that was the reason that the lease time was only 30 minutes. But with the introduction of KEA and the issues were solved in the network, we decided, hey, let's go to a longer lease time. So we decided to go to 24-hour lease timers. Now, two reasons for that is that we have more time. For example, if you have a major outage of both your DHCP service, then you have up to 12 hours to fix your issue. With the old situation, we had only 50 minutes, and that's pretty low. So if you have a major outage, within 15 minutes, clients will drop their lease. Their lease will expire, so clients will go offline. The next side effect is that you have lower load on your platform. So that's also a pretty nice side effect. Yeah, then something about what I told before about the lease affinity. Lease affinity means sticky leases. So at Delta Fiber, we go for sticky leases. That means if you got a lease that's bind to your unique SP0 code, you will always keep that lease. So even if you swap your device, like it's in the picture, you will still keep the same IP address. And that's sometimes very nice. For example, if users have a public IP address they use for their own server, they will always keep that same address up to 30 days. We have a lease There's a tool running within Kea that if a lease expires after 30 days, the lease will be deleted from the database. So if within 30 days you do a renew or a discover, you will get the same lease. One thing I discovered within Kea is that a lot of CPEs, if you do a reboot of a CPE, then they send a DHCP release message. And in Kea, the DHCP release message is handled as I delete the lease from the database. So in the first test, what I saw is that if I did a reboot, I got a new IPv6 prefix. And that's not something you want. You want to have sticky leases, fixed addresses. So we need to add an extra part of configuration. You see on the screen that all the release messages in v4 and v6 will always get dropped in our case. And that's the way how we fixed it. It was something that Kea also advises to do. Then something about how we built the whole DHCP platform. And on the right side, I have a small diagram of how we build it. In the center, we have the DHCP manager. That's the whole provisioning process. And the DHCP manager is the connection from our OSS systems to the actual DHCP platform. First, you have all the networks, so all the subnets and the routers we have in the fields. And that's in our Nautabot CMDB. So we use Nautabot for all the registration of subnets. The DHCP manager fetches all this information. And on the other side, you see the host reservations. And host reservations are, for example, if a user wants to have a fixed IP address or a public IP address, we have a separate entry and we flag that this user needs to get a fixed or a public IP address. And that information is pulled together. DHCP manager provisions it to a so-called master DHCP server. That's a DHCP server that only does provisioning. So it doesn't do DHCP itself, but we use it for the provisioning. The DHCP manager sends all this information to the API. And the master server also runs a Postgres master database, and we have a lot of slave database that get all the data replicated from the master. The reason we did this is because we have a lot of DHCP servers that needs to have always identical information. We don't trust the provisioning process, but we trust the replication process. So the master receives all the information, and all the information gets replicated by the Postgres replication mechanism, and we trust that replication mechanism. And that works pretty fine. So we can always rely that both slaves have always the same information, because they can have to serve the same request. So you need to have that identical. Only the lease information that's not in a database and the lease information is synced via the API of Kea itself. So the slave service sync that lease information between each other. One drawback of this solution is that if you want to do an update of Kea, some updates need to have a new database scheme, then you need to update as well the master as a slave in one run. Because if you do a reload and you have the new database scheme, Kea checks if the database scheme matches the version. So that's one of the drawbacks. That's also the reason we have multiple masters. So we have a master for internet services, for VoIP and for IP television. We have separate masters, so you can do the upgrade easily. And last but not least, the whole platform is managed by Ansible. We have a wonderful team of engineers that are very good at making Ansible playbooks. So they make a playbook that we can easily roll out new slave servers or update slave servers. Then the migration to Kea. Like I said, Delta has 5 different DHCP clusters on almost 260 routing areas in whole the Netherlands. So 260 different POPs that have routers that have their own DHCP relaying running. And the 5 different clusters are VoIP, IPTV, Internet v4, v6, and we have also some management DHCP server. We decided to start with the easiest platform. In our case, that's VoIP and IPTV. The reason is that we have just single pools, so we have no fixed IP addresses or clients that need to have always the public address. So it's very easy and it's very clean setup. And also we started to do it with pre-production. So we have one router that's actually in production, but that has only customers from the lab or friendly users. So we can easily do migration. And if we have a mistake, we don't have customers that will call us. And also the plan is crawl, walk, run, fly. So just start small. And if everything goes well, build up so that you can speed up the migration. At this moment, we have done the whole migration of VoIP and IP television, and we are currently doing the IPv4 migration. I think we are at 80% of IPv4, routers in all the Netherlands. So we are almost finishing it next month. So if you are a Delta customer, it could be that you have a moment that you will be migrated, but if everything goes well, you won't have any impact on it. And the last step is that we also manage the V6 and the management service. Those services are running KEA, but they are running a very old version, so they need to be upgraded and migrated to the new platform. Yeah, then the most technical part of the presentation. How do you migration without impact from the old to the new server? I try to make it in a diagram. First of all, we have a migration script. We built it ourselves. You can also get it from from ISC itself. They have some scripts, but we created it ourselves because we have our own CMDB. The first thing we do is we add new configuration to the router, so the relay routers know the new DHCP server. And then we import the existing leases from the ISC DHCP server. Those leases will be exported to the new KEA DHCP server, so all information of the leases is available in the new server. Then we do a deletion of the configuration of the old DHCP server, and we change the relay settings on the router. And that is the moment that the migration will start. The users that will try to do a renew to the old DHCP server, they will get a DHCP NOG message, means that, hey, I don't have any information anymore, I can't give you that address. The user will try to do a request again, until the T2 timer, that's the rebind timer, starts. And rebinding means that the request is not unicast, but it's broadcast. And it means that the request is not sent directly to the DHCP server, but it's sent to the router. So the router gets a broadcast because you do a rebind, and then the router knows only the new DHCP server, so it will send that message as unicast to the new DHCP server. New DHCP server will answer through the router will answer back to the client, and that's the moment that the user switches from the old to the new DHCP server. So without having to do a whole restart with a DHCP discovery, you can migrate the user while it's just retaining their lease. That's the way how we do the migration. So if everything goes well, basically the user won't have any downtime doing this migration. Yeah, something we also did is we built a lot of monitoring tools before the migration to have clear insight what is going on, if there are some issues. On the first line, you see a monitoring of the pool usage, because we have, the most customers have carrier grade NAT, but we still have users that want to have a public IP address, like the freak nerd users. They don't like carrier grade NAT, and they can request a public IP. But those pools are very small, so we need to monitor the pool usage, and we give alerts if pools are running low. You can see it here. We also monitor for DHCP packet anomalies. For example, if you have a lot of discover messages, then it means sometimes that maybe there's an issue on your platform, or a lot of users don't get an address, so there could be something wrong in your configuration. The third one is the migration status for project management. So we had a project manager during the project, and what I did is, he always asked me what is the status of the migration, but I think it's easier just make a small dashboard in Grafana with how many routers we have migrated, how many subnets, so we can every day check what is the status of the migration. And the project manager finds it very nice to have just his own dashboard and see what's the status. Then we have also some detailed graph. In KEA, you can monitor every DHCP packet type, so you can see what's going on, how many requests are coming in. So for us, it's if we need to do some analytics about things not going well, we can do a deep dive in those graphs. And last but not least, we also use Elasticsearch for the really deep diving. For example, we can see on a customer level how many requests customers send. So sometimes we have users that keep hammering, and we can easily track them down and block them directly on the DHCP servers. Like I told, ISC is also a nice monitoring tool called Stork. Stork is a dashboard. If you have a lot of different DHCP servers, you can have a single view. Stork can also do changes to your platform, but we don't use that. We only use it for monitoring and have some insights of how is the platform going. So yeah, it's pretty helpful for our NOC to investigate issues. Then something about the thing that almost killed our network. We had on a Friday this year, there was a user or a colleague that decided to change Nautabot permissions on Friday. So I think that's the first mistake. So on Friday he changed permissions, and the result was that the DHCP provisioning process lost some rights to some tables. So it was allowed to log into Nautilus, but it couldn't fetch all the data sets. So it didn't get an error, it got an empty data set. So empty data set, no subnets. Hey, maybe I need to delete all the subnets. So what happened at 2 a.m. at Saturday night, all the subnets were deleted from the DHCP server. So there was no subnet anymore. What happens is clients that did a reboot or had a power outage, they couldn't get a renew of their lease. So that was the first issue. And about 4 o'clock, 2 hours later, our NOC discovered and got some alerts. Hey, there's an issue going on. So they saw, hey, the users don't get a new IP address anymore. There's an issue. Luckily, those people are very smart. They did some investigation, and at 10 o'clock at Saturday morning, the issue was fixed by putting back, restoring a backup. Luckily, we had good backup, so we could restore a backup of the day before, and everything went well. So the impact was reduced, and the reason also is we had a 12-hour lease time, so we had 12 hours to fix this issue. So luckily, we had, I think, to 10 to 2 in the afternoon, we had the time to fix this issue. Only users that did a reboot or new users, yeah, those users didn't get an IP address, but luckily, the impact was very limited. But it could have been very worse. For example, if we had a short lease time of 1 hour, then every user will be offline within 1 hour. So luckily, that helped us. Yeah, and last but not least, what we did is that was also something I advised before, and actually it was implemented after this issue. Just do always checks. For example, if you want to delete something from your provisioning system and it's more than one subnet, then you have to give alarms first, or you maybe have some cool-off period, or first inform an engineer, hey, we were gonna delete these subnets, is this right? So luckily that has been implemented. Okay, my last slide, conclusions. If you're currently running IC DHCP and you want to migrate, I think everything what you currently do in IC is possible in Kea, and much more. Especially the plugins that are available in Kea can make your life pretty easy. There are a lot of things you can do via the API, so I think it's very, very helpful. And you have all different ways to provision or to query the system. Next thing is that whole separate database backend. So having a separate database backend makes it very nice to manage your whole platform. So you have a very small config with only the essential things. Everything that's variable is in a database. So it makes it very good manageable. And also if you have a large user base, then you can just have everything in the database backend and don't need to do config changes a lot. About the stability, I think Delta Fiber is running Kea for almost 4 years now, and we didn't have any issues. So it's very stable. So we didn't have any crashes, only small things, but they were fixed in versions that came after. So Kea helped us a lot with fixing issues. The next thing about the migration, the way we migrate with including the leases in the migration, so not only new config, but also migrate your current leases to the new system. I think it makes it very customer friendly. So I always advise you to take that in account. The only thing is the Stork tool we use, that was the only system we had a lot of bugs. So if you install Stork, currently it's a bit more stable, but the first versions had a lot of issues with statistics that were not right, things that were crashing. So we also migrated to a separate server, and now it's pretty stable. And last but not least, implementing DHCP is not only implementing the software, but I think it's the whole ecosystem. So deploying a whole new DHCP platform, I think it's important to look at those things and make also good design decisions. So making good design decisions can make or break your DHCP platform. So if you're still running ISC DHCP, I strongly advise you to migrate, and I think the time is right. So that was my presentation. So
thank you, Rinse.
For questions.
So now I have a question, and the question is, are there any questions? For the benefit of the remote viewers, please state your name.
Hello, this is Andrei Tsalatka from Ripen CC. Just a small update. KEA version 3 actually dropped the proprietary plugins and replaced them with open source because they figured out that selling plugins doesn't make any sense. So it's now completely open source, and you don't have to pay support contract with ISC to get these hooks.
Yeah, it's a very good remark. All plugins are free. The only are the subnets and the RBAC plugins. So if you want to have some subnet backend, or you will want to have role-based access, I think it's very, very big ISPs. But if you are a small ISP, you can do with the open source version. Yeah, agree. I think that's a very nice move from KEA. Thank you.
Thank you, Andre. Are there any other questions? Yes.
Hello, Jakov from Nebius. Thank you for the presentation. I just wonder if you are doing prefix delegation and providing your customers with /56 of IPv6 or something like that. And is there any difference between ISC, DHCP, and KEA in that regard?
Yes, we are doing prefix delegation. So Delta Fiber, we hand out /56 to users. And I haven't done that with ISC. Within KEA, it's very easy. I know in ISC it was possible. In KEA, it's also possible, and I think it's easier than if you do it in ISC. So, yeah, it's easy to do. And also the reason we want to have least affinity, that's the reason, because if you have V6 prefix delegation and you change the prefix to the customer, that will have a lot of impact. So that's also the reason we want to have that always fixed.
Awesome, thank you.
Yeah, thank you.
All right, thank you again, Rinse. We have a small present to remember this presentation. You get only one. All right, so that brings us to the second presentation of the day. Well, there's been a lot of talk about DHCP and IP addresses and everything already. But, and the question about IPv6 prefix delegation was a starter for what's coming next. Because as we all know, in IPv6 we will never run out of IP addresses. That's been said by everyone always. So even this gives people the idea to put information inside the IP address. And the first application of that I saw was when M6 started with the idea of putting AS numbers in the IP address for your peering IP on the router. The SRv6 people, they have the same idea, so they put information inside the IP address to decide how your packet is routed. But these guys have taken it yet another step further, and all to tell us about what we can do with IPv6 is Luc Heyer, who represents the student networking team from the University of Twente. And I believe the presentation is ready. It is, so take it away, Luc.
All right. Yes, thank you. I'm going to talk to you about a little project we did at the University of Twente. So let's get into it. Wat de studenten uit Twente, IT association at the University of Twente, started 30 years ago for internet on campus because that was new and hot and internet cool. So yeah, that's been 30 years now, and we want to celebrate that. So we wanted something nerdy, something cool, public that we could do. So we thought, okay, let's make a nice canvas and let people draw by writing code. Cool. Also, fun fact, the IRC bot is older than me. So, just letting people draw over HTTP is boring. IPv4 is boring, ancient, come on guys. IPv6. And IPv6 does sure have a nice amount of bits. 128. So let's use them. Oh yeah, okay, yeah, I shouldn't. So we split the IP address in X and Y coordinates and then RGBA for color. And then that way people can draw just by sending packets. They do not have to be fully RFC compliant. Most of them weren't. So, as for architecture, we picked something with DPDK, so fast packet processing, then GStreamer for handling video, and then Media MTX for distributing the video to the 100-ish people that were watching, which is also a challenge. We were mostly PPS limited because, well, small packets. Your network card advertises 40 gigabits. It does not handle 40 megapackets. That's something we learned. We thought, okay, that was mostly enough. Split it up into 40 gig internal, 40 gig external, and then we can play around with that. The UT only had 40 gig network. We didn't want to use all of that, so we upgraded the whole university 100 gig. Yeah, so DPDK, I think most of you have already seen it. Nice library if you have to do fast packet processing. So you do not involve the kernel, you just talk straight to the hardware device, and it has some nice things where you can do really fast handling of packets. Now, video processing was a bit more fun. I thought the packet processing was going to be the hard part, but mostly ended up being video. If you've seen already at the IPv6 packet layout, we were doing some nice tricks. So we just copy the bytes to the image. So that was quite nice. And then you use an OpenCV to generate a live stream. That's always fun and nice if you test it. And it works amazingly until you get to production and people start sending noise, which, well, packets, noise, was to be expected. But at some point, you're counting not frames per second, but seconds per frame. Next time, we're doing hardware processing. That would have been better. And also, handling codecs. You have Windows users, you have Linux users. It took me multiple hours to figure out something that worked on both. Yeah, you get nice codec errors, video corruption. Browsers start doing really weird things when you just get frames per second, seconds per frame. Okay, let's see if that works. Warning, it's a bit, you don't see it. Was het command tab? Neem daar. Oh. Nou. Hoeft ook niet, als het te veel tijd kost. There we go. And then, oh, I have my mouse here. Nice. So it's a bit flashy, but you get nice things that people are drawing. A lot of random noise, a lot of logos, a lot of really weird things. Time-lapse is 1 minute, and the original was 3 days. So it's quite sped up. Ja, een brak. All right. Now, if only it stops again. And then I have to find back the slides. That's the wrong ones. So yeah, some fun things we saw. Someone, of course, we couldn't miss the bad apple and the moving DVD icon. Whoever did that, thank you, that was amazing. We also had people pinging the room temperature and the network stats of the university. This only went up to 72 megapackets because then something upstream gave up. Your monitoring and your hardware starts doing really weird things when you get at high packet rates. And also live pizza tracker. So, that happened. We were sitting in the room, people were nice, participating, and someone next to me says, "Oh, my Wi-Fi is slow." Not what you want to hear when you're dealing with packet rates in the 70 megapackets and using most of the university bandwidth. Some people may already guess what was going on. Long live Fortinet. People knew we were doing this, and it was the same people who installed the firewall, but they didn't connect the dots. It happens, but it was fun. Credits to Fortinet. They did support IPv6. They did it statefully, even for ICMP. The problem was also that they did it statefully. So 1920 by 1080 canvas, times scholars, times some people were randomizing source IPs. Not a great idea. So that was quite fun. Some statistics. We had about 100 participants, a bunch of NLNOG people, a bunch of people from Twente, so that was nice to see. I wanted to measure the packet count. The hardware counters overflowed a few times. So no total packet count, sorry. We measured 72 megapackets. We know for a fact that we got way more, but something upstream gave out. So that was fun. Saturated network card, saturated Fortinet, saturated a bunch of upstream stuff. Mission accomplished. So, of course, we want to do this again, because breaking stuff is fun. 40 gig was a bit limited. Video is something we need to do better next time, but that's something you already know about. A few weeks ago, we went to NICHAF. Talked to Tristan there. He thought it was all a little slow and limited. So we have some plans. Thank you.
So, are there any questions for Luc? Feature requests, maybe? This is going to be something about DNS, maybe, but
no,
I don't
no.
know.
Although DNS also hates stateful firewalls. No, this is Peter from PowerDNS. I was wondering, the alpha channel, does it do anything?
No, originally that was the plan, but handling alpha processing at these speeds thought it was a bit too much, and you don't really see the difference because people are just blasting over you.
Right, yeah. Okay, cool, thank you.
Maybe next year. There was also a suggestion for PCM audio.
Hi, my name is Richard van Dijk. I was wondering, can we have the source code?
Yes, it's...
I'm sitting all the way there, so I couldn't read it. Okay, thank you.
If you have any questions, come to me.
Any further questions? Maybe remote questions? No, in that case, I say again, thank you, Luc, for your presentation, and we have a small present for you.
Thank you.
And that brings us to the first coffee break of the day. So that's nice. You can just hang out, have coffee, talk to everybody. We will be back here in half an hour. So see you then.
zeggen bij mij op het werk, zeggen er is maar één tijd en dat is op tijd. Hou dit op, gaat als een weer gaat. Hier staan in de buitenblok. Als het niet werkt, dan.
Eens kijken of we hem nu kunnen unlocken.
Oh, dat is wel slim, ja.
Kijk, ik heb ook ik weet niet of je notes staat toegevoegd.
Nee, normaal gesproken wel. Maar even kijken. Oh ja, next slide, current slide.
Ja, hier zie je de current slide, hier zie je de next slide.
Ja, prima.
Dus dit is altijd wat, maar je ziet het daar ook, hè?
Ja.
Wil je nog wat last minute changes doen?
Nee, ja, dat filmpje en het... Zoals we heel even kijken, het filmpje, als ik er even op moet klikken, nog prima.
Ja, je ziet dus eerst...
bij mij is het gewoon...
Eerst krijg je dit, poster.
Ja, dat is meer dat grapje, de one more thing en dan
ja.
de video. Ja,
maar je moet hier dus nog een keer drukken en dan gaat hij spelen.
Oké, dus als ik nu druk...
Als je nu drukt, dan begint hij te spelen.
Oh ja, dat is goed, ja.
Maar zo... Dan...
Dat komt natuurlijk helemaal heel goed.
Ja, zeker. Live demo.
Nou, dit is een videootje in dit geval, maar opgenomen. Maar...
Hey, Jelly.
Hallo. Jelly? Oh, die ga ik onthouden. Jelly.
Mag je dat zo zeggen?
Jelly? Ja, hoe spreek je het zelf uit, Jelly? Zeg je Luje of zeg je Jelly? Luje? Jelly? Jelly. Ja? Nee, maar hoe, als je hier net werkt, bij mij heet het niet gewoon. BMP Routing. En bij jou is het nu gewoon? Nu partij, ja. Maar ik vind Jelly vind ik... Ik zeg eigenlijk altijd gewoon Jelly. Dat vind ik leuk. Jelly? Nee, dat vind ik niet leuk. Hij vindt het niet leuk. iets met personeel op. Oh, echt? Sorry, dan zullen we dat niet doen. Goed dat je het zegt. Nee, dat is niet anders. De positieve twist eraan is, binnen bijvoorbeeld de Facebook, als je dan van de community zeg maar een naam krijgt, dan is dat een blijkbaar shift.
Oh, really? Yes.
Dus als bij mij noemen ze preacher, omdat ik soms wel veel
ja, ik weet dat weg. Ik weet dat weg.
Ja, maar dat is, dus het kan ook een compliment zijn, maar ik snap het verleden maar al te goed.
Okay. Ja, bij ons heeft ook iedereen een nicknametje inderdaad.
Jij bent gewoon de cowboy?
Nee, ik ben hackerman. Ik heb ze niet bedacht, hè. Ze zijn toegewezen. We hebben ook een collega die heet Meeuwis Vermeer. En die heet Siegel Farley. Vermeer.
Oh, mooi.
Dus, maar,
is dat speaker?
Ja, maar eigenlijk is iedereen een Siegel. Hallo Siegel.
Welcome back. If you could find a seat. And may I already ask for a small favor from every single one of you here, and also the ones who are not single. One of the perks of being in the board is that at the end of NLNOG Day, you get to clean up this room. How nice is that? So if there is something that you put on the floor accidentally or as part of planned maintenance, then please also take it back downstairs and put it where it belongs. Last year we have noticed a new trend, and the trend was that people take things out of the goodie bag that they don't like and drop them on the floor and leave them here. You may laugh, but it took us a while to get this room back in order. Could you please cooperate and make sure that we leave the room as nicely as it was when we entered it? Thank you very much. Good, good. Then let's continue our program for the day with a slot for 3 speakers, the triplets. Back in my day, which is a long time ago, when I worked at an ISP whose name was already mentioned earlier, the internet was still an experiment. So if you broke something, for instance, I broke the mail server, people started calling the support desk, and the support desk said, sorry, yes, we know our mail server is down. And the response would be, I will try again tomorrow. These days, that is different. So what do you do if you want to become a BGP expert, like Teun? I don't know. Maybe he just plays one on TV, I don't know. But you don't have an employer where the internet is still an experiment. And I don't think the internet is still an experiment. Maybe not. You have to do something to learn, and you only learn by making mistakes. So the guys here are going to talk to us about their personal ASNs, why they have them, what they learn from them, and what they do with them. It's Nick, Jelle, and Peter Paul, and they are going to take turns on the microphone, which they are going to arrange for themselves. There is going to be a video, so the laptop will work, I'm sure. And well, guys, your turn now. Go ahead.
Perfect. Thank you, Niels. The talk of this presentation is, why would anyone possibly want to run a personal ASN? There we go. Because you can is a very good answer. But we're going to take a little peek behind the curtain and first talk about, well, personal ASNs in general, and then take a look at what people are doing with their networks. So first, who am I? The boring stuff. I'm Nick Bouwhuis. I work at SpeakUp. It's just a B2B communications provider. I do their phone ops, net ops, sys ops, all the stuff. So we have a small team. And then by night, I have a small business with which I help small other entrepreneurs in the region of Twente with their hosting or other IT needs. And I think 2 years ago now, I got a nice title from Cogent, which I take by heart. It is the Internet God and Network Supreme Ruler. This was the first email I got from them, and well.
Maybe you have followed.
Yes, but I like this title, so if you approach me, please approach me by this title. So, I am a NOC engineer at SpeakUp. That means I manage a network there, which was already there when I started working there. And well, it is production, right? There's lots of VoIP traffic, lots of critical traffic going through there. So even though I manage an ASN for my day job, I also have a personal ASN. But what is a personal ASN, you might ask? Well, I think BGP.tools defines it pretty nicely, which is that this ASN is run by a single person or a very small group of people for hobby, educational, or an infrastructure needs, basically for experimenting. And there are dozens of us. I have some numbers for you, literally dozens. So again, I use BGP tools for this because they have a pretty nice list. There are 1,354 listed there, and 61 of those are in the Netherlands. And only 25 of them are IPv6 only. So lots of people have IPv4 space to announce. But why would you want to do this, right? It's costly, it costs a lot of money, it's very time consuming, and it's work. Nobody likes, well, maybe some people like work, but outside of working hours, I'd like to relax in my own way. So the whys are that you have total control and freedom over your network. So when I started my job at SpeakUp, things were done a certain way. We use certain platforms, but maybe I want to experiment with different platforms or try out some new provisioning or automation systems. My own network gives me the freedom to actually experiment and do stuff with that. It also allows you to get some real-world experiences. So you get to also communicate with your peers, with transit providers. You maybe need to make some nice deals. You have to set up monitoring so you don't go over your commitments with your transits and get a nice bill.
And if you are aspiring a career in networking, and you tell the recruiter or whoever you're talking to at the company you're applying to that you have a personal ASN, then, well, at least in my book, you have a head start. So, next up, I would like to address some criticisms. Some of you maybe have seen this article on the Ripes Lab blog. And these criticisms are the following. Hobby nets are irresponsible and mistakes affect everyone. Irresponsible is not the word I would use. It depends on the person running the network, I guess. And yes, mistakes can affect everyone, but it's also a very, very good way to learn. And there are yes, and there are ways for your peers to make sure that mistakes by a hobby net or another company doesn't affect the network very much, like setting up good filtering or implementing RPKI. And also, big companies also make mistakes. So it's not just the hobby nets that are responsible for your downtime. Then there's the argument of using alternatives like GNS3 or DN42. And these are very nice, but like Niels already said in the intro, you learn by making good mistakes. There are good mistakes, yes. While these are nice, at some point you want to move on and you get new experiences from running a personal ASN. And the last argument, they pollute the RIPE database. Well, I'm sorry. If you check the WHOIS record for my ASN, then there might be some ASCII art in there. But this is talking about not putting address data in there or misusing it. Again, just tell those networks that they are misbehaving, and we will fix it. Most of us are responsible human beings. So, let's talk about my personal network. It's mostly a content network. I called it bgp.rodeo because I wanted a bgp.something domain, and then I scrolled through the TLD list and I found .rodeo, and that's pretty nice. You might have also seen this name on the leaderboard, dashboard.eventinfra.org, the top 20 ASNs. I'm on place 2 because traffic is tunneled through the SURF network, so SURF will always be number 1. But yeah. I'm number 2, yay. So my network is currently, well, this is 2 switches and a Dell R630, which has multiple duties. It's a hypervisor. It runs a web server, for example. It runs BER2. And these switches are connected to a couple of places, like SpeedIX, FreeSix, FuseX, AMSAX, InterDC, and Net1, which is right over there. I want to, well, everyone here deserves a shout out because they connected me for free or for very little money. And I want to give an extra shout out to the AMCX Bright Networks Club. They saw that there's a large community of private networks here. They reached out and said that they were starting a Bright Networks Club and offered a free 1 gig interconnection to AMCX. So that was really nice of them, and I hope others will follow. And then recently I got a second location in Enschede, which is much closer to my home. To give you a picture, it's Nikkev, where this infrastructure is about 1 hour and 45 minutes from my house, and this is only 15 minutes or 10 minutes. There I only have 2 nice Dell servers. This is a generation newer, the R640. And there I am connected to the NSIX, which is an old initiative that has recently resurfaced. So if you go to InterDC and wreck your router there, then we would appreciate that you join NCX as well. Here I run Proxmox with Ceph and run a couple of VMs. Almost too much, actually. So What software do I use? I already said I use Bird. I automated it using Case, which is a automation framework thingy, collection of scripts for deploying Bird config on, deploying Bird configs. I mainly use it to do peering configuration. I'm using Bookworm or Trixie. I like Debian. It's also what I use at work. I'm used to it. It's stable. I like Debian. And then I use Netbox for EPAM and libvirt or Proxmox, depending on what location you're looking for. So what is hosted on my network? Well, I host a speedtest.net server, which does a little bit of traffic. I also host some open source mirrors, like for MariaDB or for Arch or Manjaro. And there's also my personal website, of course, and I'm forgetting stuff. But this is real traffic that's, well, doesn't affect a lot of people if it breaks, because, well, for example, the Arch mirror, there are lots of mirrors. But it's enough for me to see changes when I change the configuration. So it's nice to have some traffic to quote-unquote play with. And it also helps the community, so that's also nice. But that was it for my network. I'd like to hand it to Jelle, who's going to talk about Luja.net.
Yeah, I have the personal enterprise network. But first, who am I? I'm Jelle Lutijn. I'm a software developer specialized in infrastructure automation and also self-service. For my own I started my own network with the goal of running my own services autonomously. I just like to host the stuff myself, and that people can access that. So to start with the name, the personal enterprise network, what makes is it an enterprise? I think so, because I run enterprise-y applications. I have an Exchange server running. I have remote desktop services. I don't have SharePoint, neither do I want. I do have Nextcloud though. And I have my own Git server for Joe running in my network. So these are all services for myself. Architecture highlights. I have 2 servers, 2 routers in Amsterdam, in NICAF, and for now in EU networks. It's run on the latest version of Bird 2. And my configuration is my own homegrown automation platform, but it is based on Case, which is the automation system by Colocluso. Thank you. I do RPKI. I also do ESPA and BGP communities. I dropped IAR filtering because it's not authoritative. Mostly American networks use alternative routing databases, and with RPKI it's all centralized, authoritative. So I trust that more than the IAR database. I also have my own pairing portal, so people can go to my website, log in with their PeeringDB account, and request a pairing if we have inter-exchanges in common. The compute of my network is at home. I have 2 WireGuard VPNs to both data centers, and it works for me, which is the most important stuff. The hypervisors are run on Proxmox VE, and I think that's more common with personal networks. You just saw the network graph of Nick's network. Mine is slightly less. It's a little bit small, but on the FreeSX port, it's on average 5 megabits per second, and once per day, around 3 AM, it spikes to 100 megabit, which is a backup. And the other is the graph of Coloclue, which is also around the 5 megabits per second. So yeah, it's an enterprise, but it's a personal one. I want to thank the M6 for the Bright Networks Club. They hooked me on the M6. Also FreeSX. I have also co-location with FreeSX/Aerotop. IPNG Networks. Net1 NL, which is one of my upstreams. And Network Association Coloclue. So, and now it's for Net1 NL.
Okay, thanks, Jelle. Yeah, so adjusting the mic a little bit. So good morning. My name is Peter Paul. And I'm going to talk a little bit about my network, what I'm doing actually. And we called it actually a nickname because we prepped this presentation with 3 of us together. And we said, okay, what could we call it? So personal networks, and of course there's some ambiguity on what is personal, what is professional. We had a chat with Niels, I think, a few minutes ago. But we nicknamed it, so personal content networks, personal enterprise network. So I thought, okay, let's call it my network a personal carrier network, because that's the role I'm fulfilling. And there was something on the bingo, I think. Let's say that my network is a tier 3 carrier grade network. So somebody can now press it in the app. So no, I'm not having it say a tier 3 carrier grade network, but I do fulfill a tier role or a carrier role, you would call it. By the way, I'm not a network engineer. I don't have any background in that, so I'm really a really funky person in this room. So I work at Red Hat, implementing all kinds of platforms, open source implementations, culture, processes, etc. But I love to have new challenges, do new things. So that's the reason that I thought, okay, let's dive into this world. So a long time in a galaxy far, far away, and I'm not sure who is a Trekkie or a Star Wars fan here. Don't raise hands, don't raise hands. It's like, I'm now 41, and then about, I think, 20 years ago, so Sebastian was already mentioned in the first slide by Teun. He's a long-term friend of mine. We were doing some beers. I was like 22. And we were like, yeah, what would be a cool project? Oh, yes, let's request PI space from RIPE. You can imagine 20 years ago. Now IPv4 is exhausted. And then we thought, well, that will never, ever going to happen, because me as a natural person requesting a PI space from RIPE, that will not happen. And I'm not sure who of you requested PI space or IP prefixes, I think 20 years ago, but we still had to do it with a, you did, Niels? Okay, you had to do it with a TXT file at the time. Can anyone remember that? So you had to fill in a TXT file with all your information. So we thought, well, you only live once, we just enter that information, and we will see what happened. Me not, let's say, having any clue that it would really happen. So, a few days later, boom, it still got assigned. So it was like, oh shit, and I got an IPv4 prefix, at least it was assigned. And then, to be honest, for the people that notice me, so I'm really proud it's PI Legacy, by the way, so really fun. You can see it's created, 2006, and I'm not hoping that now there are really official RIPE employees here in the room. When you check really well on the route in the origin created, you can see that it was not, let's say, being originated by an ASN until 2 years ago. So I was in the position of a PI prefix for, let's say, 17, 18 years without doing any shit with it. So at a certain moment, so I mentioned Sebastian already, we were chatting like, and yeah, we made, let's say, literally plans for 10 years. Okay, Peter Paul, you're going to build your own network and do some cool stuff with it, etc. I said, yeah. But the whole problem is that, of course, that it was quite expensive to 20 years to do that. If you want to have a peering transit, now you have, of course, M6 and FreeSX and LAX and all
cool exchanges which you can connect. But at the time, for a student, it's impossible to pay. So 2 or 3 years ago, I was discussing with Sebas, and we said, okay, let's get a move on, and now let's start building. So I set for myself a little bit of a goal. I talked about this on your podcast as well, Niels, is like becoming from an open source company. So I like, okay, when I have this stuff, I got it for free, the PI space, now you need to pay for it. I thought, okay, let's make good use of the IP space and use it for other folks as well. So I'm not into enterprise networks or into content, so I figured out, oh well, why not fulfill some sort of a carrier role? And that's what I actually started with. So my goal, providing a super fast community network for almost for free. So I will be honest, having a network, and I think the gents behind me know this as well. You cannot do that for free completely. It's impossible. I did it for free the first year, I think. Yeah. So for everyone, but the connections now grew a little bit. You will see the platform a little bit. But I want to build this platform almost for free for everyone. So if there are hobby projects or initiatives, Luc, you cannot come with, not say where Luc is. He was like on a massive package, etc. Oh, there, Luc, yeah. So not that kind of traffic yet, but I will have a sneak preview later on that part. So perhaps, and to offer that for other people. So it's also a shout out to if anyone has a hobby project, you can connect with me in 2 data centers. So due to time, a little bit, okay, how is then my architecture being set up? A little bit different, you could call it, but similarities with the folks behind me. Also using Dell servers. Really cool, I know the Dell folks here in Amsterdam, a few kilometers away. Discussed a lot with them, okay, how to do the hardware setup specifically. Using Arista switches in NICAF, I'm currently at 2 locations. So NICAF, of course, where there are a lot of IXPs at this moment. And in Cupra, so where's Arend? Somewhere Arend is sitting there. Arend provided me a wave to Cupra, so you can also plug in there. Really cool. And then, of course, running Proxmox as well with, how can you say it, of course, RHEL VMs as routers. I drink my own champagne very proudly. And then, of course, vector packet processing. And the reason behind why I use VPP, Nick already knows this. I will tell you in a few minutes. And by the way, don't tell anyone, and I know some of my Red Hat colleagues will be dialing into the YouTube stream. It's now running Proxmox, but before I had VMware. So it's now recently changed to a full open source stack in this case. Lastly, case, of course. I saw Tijn sitting somewhere here as well. I think how many hours we spent in an evening to really fix case, because I have a 32-bit ASN. And then we spent a lot of time stripping out the classical BGP community prefixes and functions, etc., and to make it into large communities, of course. So something I didn't really know any stuff about. Okay, how much capacity? Almost 160 gigabits of external capacity. So that's not, let's say, 1 or 2 ports. It's a little bit more than, and I'm still expanding. And then specifically mentioning also resource isolation. So we'll go into that about VPP in a few minutes, why I need to do that. You can find me in BGP tools and PeeringDB, of course. Some highlights. My goal, based also a little bit on my previous work before my current employer, is like I want to build it as enterprise as possible within the constraints and the time that I have. So for me, it's like, okay, full-on monitoring, Libre NMS. Everything is with desired state configs in the netbox, IPAM circuits, until the DIM modules of the servers, till the fans, everything is there. Of course, using Ansible to do all the configurations as much as possible. Still working on the full desired state config with webhooks from netbox to Ansible to the devices. Some of them work, and there's a talk later today on Terraform and some other network automation, so looking forward to their IDs. All code in GitLab, everything, so the whole case, the whole playbooks, everything is there. All the documentation is there as well. And then, of course, the whole enchilada of monitoring tools. So we got a Signal group with the 15 of us, 15 people behind me now as cone. Regular updates, Matrix does all the monitoring, of course, with all the stats. RIPE, Atlas, of course, and some other hobby projects. Uptime robot monitoring, everything worldwide. 3-4 different smoke ping locations from across the world to measure performance if everything is going well. And of course, famously NLNOG and some mirror services as well. And last but not least, so if you have, let's say,
personal carrier network. You need to also do some testing. So since about a year, I also got a test ASN, so where I have a copy of the whole network almost, with the same technology, the same packages, the same approach, and a copy of case and the tooling to also do testing. Because normally you could say, I just shut down my network and it will be fine, but in my case it evolved a little bit because there are like 15 people now using it. So you want to keep the network as much as up as possible and do the testing up front. To conclude, a little bit of a picture. So this is my setup in NICAF, Arista switches. It's 31 ports now connected. Special mention to that small cable on the right. So people who know the switches, it's a 7280 64. This is a 40G link. This is from Asimo. Thank you very much. Transit 40G, really cool. So still not full. So if there are more projects, Daniel promised me a 100 gig port. So if there is more traffic of anybody here, come over. I can get a 100 gig port. Would be nice. Last, so this is one of the lot of the dashboards that I'm using. Libre is monitoring all the ports. You can see NLIX and M6 as well. Thanks NLIX, I got a cross connect from you as well. Really, really helpful for the group here. Traffic. So I'm doing a little bit more traffic. So it's about 1 petabyte per month in volume, like with an average of 3 to 4 gigabits continuously, and it spikes sometimes. It depends a little bit on, I think, whose mirror? It's like your mirror, huh? It spikes to 10 gig, depending on the time of day. Some last points, war stories. RP filter is a batch. So we spent, I think, a lot of hours in the beginning of the network to finding out that you need to do specific settings, at least on Linux, on doing the RP filter setting. Otherwise, you never get any visibility in the DF set. So it was really, really difficult, of course. Typos, we made a lot of mistakes in the YAML files of BERT and making mistakes in case and rechecking the code. So that was really sometimes hard to find out. Linux routing can be done, of course, specifically with VPP. And I mentioned VPP, or vector packet processing, for those of you who know it, specifically because there was somebody in my group, I will not mention him, who was doing a lot of packets per second. And if you do the classical routing on Linux, then let's say soft IRQs are killing you on the network side. So the whole reason that I moved to VPP is because of Nick, because he had certain traffic patterns which require that. So. But then the challenge came, of course. So for Red Hat, there are no VPP packages. So Pim does a great job in building that for Debian and Ubuntu, that kind of stuff. But for RHEL, there's none. So I spent almost 3 months getting those packages to work on a RHEL-based or CentOS-based system. But the result is rewarding because in the end, when I had built it, the router stayed almost up for 1 year. So the VPP daemon, including BERT, stayed up for 1 year. I think that's really awesome. And it's really stable now also to provide some services. So it's a rabbit hole. And it is, so we talked about Niels, it's really, I think the networking art is really a craft which you need to master, which takes a lot of time. So that's not time that I always have with my current work, but it's a cool area to work with. And I see a lot of similarities between the open source communities that I work with and like this community, because similar goals, sharing stuff, cool things, projects, etc. So I would say keep up the good work. And last, for those of you who know it, we love oranges. My mantra, I had to remind, okay, how can I do BGP traffic shaping? Of course, we love oranges as refreshment. So to conclude, some plans. I want to use Acforado for S-Flow, VPP to 25. I'm still running 24, but I need 25 for Acforado for S-Flow. PM Transit Portal, perhaps I will fork it from Jelle. Some DDoS or upstream, so NAWAS or NBIP would be nice, because we have a lot of folks now behind me. Rancid Oxidize for the monitors, for all the switches and all the routers that we manage would be good. And more locations where people need me. So I recently opened with a DWDM wave in Cupra, but if there are other folks like, oh, I want to have something there, and perhaps one of the sponsors, which I'll mention on my last slide, has an on-net location there, I'm happy to put some stuff there over there as well. I'm not charging Mbit traffic or something. You can just plug and use whatever that you want. I do ask always, and that's also with the group, to contribute to the community. So some people contribute some money, some people contribute some code, or some other time, and to help each other. And then last but not least, I think then we're on time. One more thing, always, that's really cool. So I have a hobby as well, another hobby as well, I've got a lot of hobbies, is a little bit of a smart home, 300 devices, 3,500 data points. So I figured it would be cool if I can also be lazy, because IT guys are lazy by inherently. So I figured, why not connect my whole network, AS200-150, to Home Assistant, because I want to ask, let's say, the status on some stuff of my network. So giving you a little bit of a sneak preview, and let's hope it's going to work with audio as well. I think I need to press space again, right? So what I'm doing here is I'm asking now to Alexa, what's the latest status of my network? It's a video that I recorded, so not live, sorry guys. But let's see if this is going to work as a final closure.
Transit status.
The NICHF1 router has currently 3 established transit connections active.
So, okay. So it was the last gimmicky. So what happened in the background, there's a whole node red flow, which then directly connects via SSH towards my routers, which are via an out-of-band network. And it really pulls live data. So this is not a, let's say, pre-recorded voice. And it really extracts all the data. It does some grabbing with like, okay, how many transit connections? Niels is one of them. And then it counts it and then puts it in a payload. And then I can ask Alexa, okay, how many transit connections are active? But I built equally stuff for like, okay, how many DFZ routes or how many members are online or anybody else. So. Last but not least, with a little help from our friends. So guys, so Arend from 36, thank you very much. I got 2 ports from you, really cool. Asimo, as well. Got 40G, but I want to expand. So Teun, thanks a bit for the connections as well. And of course, the other people, I think I already mentioned Physix, IP&G, PIM, support a little bit in coaching on vector packet processing. And of course, M6, thanks Lionel for the 10G connection. And of course, NLNOG, which is really helpful. So that was it, and I think we can now open for some questions.
Yeah. But we have also a shout out to Coloclue. If you want to play with this, well, you can request resources if you want, at Coloclue, for example.
There are questions, I see. Will.
Yeah, hi. I'm Will from AS2613. I was wondering why you went all for Bird and not FRR or like hardware router. I suspect the price, but you could recover some old device that were laying around. Mine is running on Cisco 7206 VXR still. Sorry about that.
Okay, I will answer this one. I chose to go with Bird because I am also a volunteer at Coloclue, and they use Bird already, so it was an easy one to go with that.
Yeah. Okay. Okay. Thank you.
I can also add to that I tried different routing engines. One of them was the Windows RAS. It doesn't like full tables very much, I can tell you that. It's, I would not recommend, but feel free to experiment.
Hi, I'm Marlies. I have AS214723. If you want the sticker, you know where to find me. I was wondering if you were all so smart in 2006, or did you find another way to connect to some of the exchanges I saw listed that currently, as far as I know, require a certain amount of IPv4 space advertised? And if you're one of those exchanges and you're here, maybe drop that old-fashioned requirement?
Yes, I can answer the question. Probably 2006. So for me, it was like it was too expensive at the time. So what I did in the meanwhile is, let's say, I lended my space to Sebastian, and he used it for some stuff. So he announced it. It was not completely out of the DFZ. So he lended me for almost 10 to 15 years. And we did have some vague top tunnels from my home towards a vague router somewhere to get it at my home. So now I got partially of the 24, I got it at home, but it's now much more easy to build those connections, of course. So at the time, it was much too expensive. And now you got free ports with a lot of the internet exchanges, a lot of the initiatives, which really helped in building such stuff, which of course helps also the community, because for people who are, let's say, still students, you cannot expect them to pay 500 euros a month for like such a hobby. That's, I think, not doable. Yeah.
No, but how do you get around requirements like that for your colleagues, so to say, who don't have the foresight in 2006?
Yeah. No.
For me personally, it was asking around in my network or in communities, and through there I found someone who was willing to sell me or lease to me IPv4 space. That is one of the biggest expenses currently for my network, leasing IPv4 A/24 IPv4 space. But yeah, I agree. If your IXP requires IPv4 space, then you're old-fashioned and you should change your policies. But yeah, nowadays, if you want to get started, the quickest way is to, unfortunately, lease IPv4 space and yeah, spend a little bit of money on that. Hobbies cost money, and it's unfortunate that we have to spend money on legacy resources.
Thank you.
Robin.
Also, in my case, I became a couple of years ago RAI player, which, by the way, is a very expensive hobby. Don't do it. I sold that space and I switched to PI.
Now, Robin. Then.
Yeah, Robin Guillaumessen, related question. I don't have an ASN. Where do I get one, and what does it cost?
You can get an ASN sponsored and also an IPv6 prefix sponsored with a layer, and well, Coloclu is one of those. And in case of Coloclu, we just charge what RAI charges us.
Which is?
For IP prefix, it's 75x VAT, and for an ASN, it's 50x VAT a year. And you also need your yearly contribution.
You need to think as an entrepreneur, Jelle.
Hmm?
You need to make a margin.
Okay.
Anyway, I'm sure you two will connect later on. Yeah.
Okay, Arend gaat vragen stellen.
There's a question from Arend.
Oh.
Now we get it.
Oh, now it goes. I'm sorry. I first need to come clean because I'm a legacy guy. I like IPv4 more. I'm getting old, so I can't remember all those letters and numbers.
I think you also have a personal ASN, right?
I do, yes. It's also a 16-bit one because I'm really old. But what I wanted to say, I heard the question about the people needing IPv4 to announce on IXPs. We at FreeCX do things a little bit different maybe because since the beginning everybody is welcome, and if you don't have IPv4, you are also welcome. And if you buy some later, then we can just add the IPv4 to our route servers, no problem. So if you want to connect with us and you are in one of our data centers where we are available, very welcome if you only have IPv6.
Teun.
He actually likes IPv6. I don't know.
Of course he does.
Okay. Actually, I'm curious. What did you break running your routers? Because you had the slide on why you shouldn't be running private routers on the internet. So, did you guys break anything?
Did we? So I made sometimes with the case configuration, for example, so that it removed all the filters. So all my peers, so all the members were down, like 15 people at once. But luckily, the way that case updates itself, that really helps. That was one of my biggest ups. I didn't have any route leaks, so that was really cool. Also not, let's say, IPv6 router advertisements on an IXP. And one thing that I did is that I made the mistake on my VMs to do also an MTR with DNS lookup. And then I got a netlink buffer overflow of the Linux kernel. And then it was like, the route was like, then the router crashed. So that was not really handy to do. So I learned from that as well, but I never make that mistake again.
Thanks. To be clear, I think experimenting on the public internet should be done. Because if we don't do our job very well, it shouldn't be your fault that our networks break. We are responsible for our own networks. Yes.
Final question from Arjen.
Well, it's not really a question. I want to correct something.
An IXP as M6 never ever be demanded that you announce IPv4 space. The only requirement is that you have an AS number. And if you don't announce anything, and there are, I know, members of the M6, at least in the past, that didn't announce anything, that's fine with the Internet Exchange. It's different if you want to peer with somebody else, that somebody else can have requirements, another AS, like I want you to announce, I want you to exchange a certain traffic, but that's not a requirement of the IXP. It's a requirement of your peers. So I wanted to correct that.
Thank you for that correction, Arjen. Yeah. All right, guys. Well, thanks a lot for your presentation. It was a big one. And that means we also need to shell out for 3 presents.
Yes.
But I'm sure the guys will like it. Peter Paul will put this in his home automation immediately.
Absolutely. Oh.
I am absolutely sure. Now we have another talk where the title starts with the word why. Because here the guys were talking about why do they have a personal ASN? And the next talk is going to be why do we need 400 gig? Well, no, not really. It's about the event why, obviously, and the 400 gig uplink that the gentlemen on my right have provided to this event. Well, guys, 400 gig is not nothing. The question is, how did you do it, and was it enough? I'm curious.
Hello. Today we'll tell you something about the 400 gigabit fiber to the home connection that we've built for Y. Does this work? Okay. Yeah. Fiber to the anyway, this is Nico, and I'm Arjan, and we've both been involved with the NLOG team for Y 2025. Why did we build this network? Well, it's fun, and hackers obviously need internet. So Y 2025 is this year's Dutch hacker camp. It's a multi-day outdoor non-profit camp/festival. And with the team of volunteers, we've built a decent-ish scale temporary ISP with its own AS number, IP space. We have an on-site fiber infrastructure, and we had about 60 datenclos. If you're interested about this kind of infrastructure, there was also a talk last year at the NLNOG Day, so you can watch that back, and it goes into more details about what kind of infrastructure is being deployed there. So the Dutch hacker camps, they have been going on for quite a while now. The first one was in 1993, and going forward, each 4 years there was a hacker camp organized. And throughout the years, the bandwidth of the uplink also has grown considerably. And in the last couple of editions, we actually managed to each time double the speed of the uplink. But of course, it also still needs to remain practical to do so. So for example, in 2013, we were in Geesmer Ambacht, which is a site up north of Alkmaar. There we actually had to install 3 kilometers of fiber ourselves, which is not really something that we would like to repeat in future events. So when we, in 2017, when we moved to Zeewolde, we were lucky enough that Eurofiber was already on net at this site, so it was quite doable to get a dark fiber connection to NICAV. And so for the 2025 event, we were back at Geesmer Ambacht site, but since years has passed, there was actually fiber to the home connection installed at the field itself, so that was quite convenient. And for the event, we were able to use the uplink as a dark fiber connection, but the only challenge is that this fiber to the home connection is only a simplex fiber. For MCH 2022, which was still in Zeewolde, we worked together with SURF, which is a quite nice cooperation. And so we wanted to work with them again for Y 2025. They offered us in Alien Wave, so it's a DWDM channel on their infrastructure. And with that, we were able to build a 400 gigabit link from NICHEF, which is where the equipment from Eventinfra is installed, to in Holland in Alkmaar, which is one of the customer sites from NICHEF, from SURF. And in the last slide, we talked about the fiber to the home provider we had on the site. But yeah, we still needed to bridge a gap between SURF and the fiber to the home provider. And for that, a 35-kilometer dark fiber was rented. So we ended up with 2 400 gig links, and they were connected back to back in Holland, Alkmaar. Right, so yeah, 400 gig simplex, 400 gig over simplex, how hard can it be? Well, we included early on enough that we needed to be using some kind of DWDM technology because of the distance and the loss of the fiber. So we had about 50 kilometers of dark fiber. And yeah, we were inspired by EMF 2024, which is the UK-based hacker camp. And what they did there is that they deployed a 4x 10 gig BiDi solution using DWDM. And what they used there is a 8-channel MUX. And yeah, they put the RX on one channel of the TNG link and the TX on another channel. So we wanted to do something similar, but then with 400 gig. And what we did is that at least at i2d.net, we had some ADVA equipment laying around with 400G, so we tried some tests with that, but that did not work. We tried to put like the RX on one channel and the TX on the other channel. Yeah, it didn't work. We mailed with ADVA, and they said like, oh yeah, no, that doesn't work. You need to buy this other product, and then it might work. So what we learned is that with the current coherent technology, the RX and the TX frequency always needs to be the same. Yeah, so we ended up asking around on NLNOG IRC if people had any suggestions. One of the suggestions was to use an optical circulator. And with optical circulator, the RX and TX frequency can actually be the same. But the downside of the optical circulator is that if you have a lot of reflection and loss on the fiber, then you can have some cross-channel interference. So yeah. We thought it would not work out. So we did actually get a couple of circulators from Arendtje. Thank you very much for that. But we did not end up using it for this 400G link. But, yeah. Yeah, and so when we were chatting on IRC, then also Nico, he came up with a somewhat cursed idea, which he will explain about a little now. Yeah.
Yeah, so we knew what does not work because the coherent optics are really good at filtering the receiving light. The circulator was the problem with the KPN dark fiber. Some of you have already experienced KPN dark fibers. So we weren't really sure if the reflection would meet the requirement of having a circulator connected to the normal DWDM optic, or if just all the light would come back and destroy the link. But what if we use more optics? What if we use a different optic for TX than for RX? The problem with Ethernet switches is that they care about link state. So when you plug in an optic, it won't push traffic out of a port if it doesn't see a link on that port. But that's mainly an issue with Ethernet or other more intelligent equipment. It's not so big of a problem with DWDM active equipment, which just does basically an optical-electrical optical interface. Some of them happily accept data on one port and will push it out of the other port and vice versa without receiving any lights. Thankfully, we had some smart optics equipment at the place where I work because we are currently upgrading our network as well to 400 gig, and especially for customer lines, we don't want to have the coherent colored optic in the customer equipment. We want to have it in our vicinity and then just hand over normal LR4. And with these smart optics stuff, I tried it at work and it looked quite promising. And then KPN delivered the line to the field, and we found out that the 50-kilometer fiber line from the in-Holland POP to the local site has over 20 dB of loss, which is roughly 1.5 or even more than what we expected. Coherent optics, the ones we use, have around 20 dB of power budget, so that was a bit of an issue again. So to make the setup even a bit more complex, we decided that we needed amplifiers for that. So this is the lab setup we did before the event. I will also have a schematic drawing in a minute for that. But you can see on the top left are the two smart optics multiplexers. You see the green optics are the client optics connecting to the active Ethernet switches, and the white optics are the colored 120 kilometer DWDM 400 gig optics, where only one of the ports is connected. On the upper left optic, you see cable I think on the RX side, and the upper right optics is sending the data. In front of that, you see a 40 kilometer fiber spool on the bottom to simulate the link, and because that was not bad enough, I had to add like 10 dB of attenuation to that to make sure that we are as close to the local fiber as possible. I couldn't add much reflection though. And on the right side of the slot, so that's a one rack unit chassis, you see the amplifier, which we used to boost the signal before feeding that to the optics. It worked with a circulator. That's the small cable mess on top of the fiber spool. But in the end, we found out that the 4-channel DWDM MUX has less attenuation than the circulator. And as attenuation was already a big problem, we tried our best to have the least attenuation, at least in our equipment. So we went with the DWDM MUX instead of the circulator. But that would have also worked in that setup with a different TX and RX frequency. This is the schematic. On the left is our trusty home router connected to the 400 gig link. And then that cable gets split on both ends and fed into the DWM active multiplexer we have. So the client 1 port is sending out data and being connected to the RX of our router, and the client 2 port is only receiving data. And from that on, it's just changing waves, going from the normal LR4 optic to a SATA Plus optic, and connecting to the DWDM MUX. We use the amplifiers on the receiving side, as it's quite common in carrier networks. And in between the side, we had the single fiber strand connecting that. The right part of the image is clipped because that's just a boring normal 400 gig DWDM link over an amplified network, which some of you might have already built, or some will have yet, will build it in the future. But these are the most important part. At the in-Holland POP, we had to convert from a normal 400 gig link to the 2 BiDi setup. Thankfully, the smart optics has 3 times 400 gig, so we made perfect use of that. And also to make the cabling a bit more complicated and fun, we decided to not use 1 times 400 gig in our equipment, but split it up into 4 times 100 gig, which is a bit fun on the cabling. You see on the top right picture, this is the MPO breakout box we used in Holland. The first third of the thing is the 4 times 100 gig from NICAF, and the 2 other parts are the 400 gigs or 4 times 100 going to the field and coming back to the field, where only every second LC simplex port is used. During the build, we had one of the fibers in one location swapped. Quite to our surprise, the link even came up, but we had different LLTP neighbors on both ends because we basically built a triangle of devices. We used LACP and BGP, so no data has been harmed in that, but it still was fun. Also, we found out that when you unplug a circulator, you will have a total reflection on the open end, and you will loop your management network or whatever you've put on the circulator before to try that. So this is the top right picture is our pop-in in Holland. The upper line is the MPO breakout box we used. Then we have got a DWDM multiplexer to multiplex onto simplex fiber going to the field. The next device is not ours, it was just there and happened to be in the picture. And on the bottom you see the smart optics device again with the 3x400 gig on the left and the EDFA amplifier on the right. This basically gave us 6 dB of headroom. So in case anything broke again on the way to the field or on the field because someone tripped over the fiber, we would still have had some margin to correct that. We built a nice dashboard to get all the 400 gig coherent data into Grafana and see what was going on in the fiber and monitor that a bit, especially because with the coherent stuff you can monitor some nice physical impact on the fiber where the light can rotate and attenuation will change over time. You see that on the Q factor, which isn't steady at all. You see we had a power outage on one time where where the line dropped and then came back again. But you also see that there is no data for some of the optics, like the zeros you see on the right, which is the prefec, because 2 of the optics aren't receiving any light. Also, the same is for the dispersion on the top and some other values, because when you aren't receiving anything, you will get no data of that. So if you build something similar at your workplace, probably don't, or somewhere else, be prepared that questions will come up why there is no data for some links or the stuff looks weird, because this is not intended to work, but it works. Even the Germans, our German sales representative of Smart Optics was quite surprised that their hardware could do that, but thanks for that, it works. I would do it again. Probably not at work, but definitely for other fun projects. Do you have questions?
Yeah, I was expecting people to stand up and ask how to do this in their homes.
Well, the nice thing about that is you saw that we used the 4-channel DWDM Max. So scaling up that to 2 times 400 gig or 2 times 800 gig is just a matter of money and optics, but nothing else. So just throw more money on that and you will get more bandwidth on that.
Like any problem, thank you. I see that there is an internet god and supreme network ruler at the microphone.
Thank you, Niels. You've given me great inspiration for my own network, so thank you for that. Yes, that too. Now my question is, how much of this bandwidth was actually used? What was the biggest traffic peak you guys saw at Y? Because
yeah, we've got an infra review. It's up on YouTube, Media CCC. I don't have the number with me this time. We just focus on that. Not a lot.
Just under 100.
Yeah, 100-ish. Yeah. But we wanted to keep up the pace with doubling the bandwidth. Yeah. And especially solve that problem when you don't have to, but you want to.
So 800 gigs at the next event then?
Maybe.
Game's on, yeah.
Thank you.
Will.
Will, operator of BiDi network in Lausanne. I'm really interested in that one. I was curious about the price, actually, of these optics. I think like a 400 gig optic is like around 2K, 1K, something like that. And what about the MUX?
Well,
rough idea.
The coherent setup plus optics, the 120 kilometers are way more expensive than that. So we had to use the really expensive ones because that's tunable and we need a power budget. So these were the high power ones, which unfortunately you can't get for 2 or 3K at the moment. They are more like a lot higher. That really depends on your vendor where you can get optics. I saw prices for 15K. I saw prices with sub 10K. So yeah, the total price of that. The smart optic stuff isn't that expensive. Okay. So the optics were the more Most of the magic was happening in the optical part. The smart optics is mostly OIO and a bit monitoring and, well, the breakout configuration, that stuff. But the optics were way more expensive on, well, they were more expensive on our insurance list, the hardware. We didn't need to buy it. It was sponsored by various companies, thankfully, and now returned.
Yeah, thank you for the information. Thank you very much.
And I think the MUX and the amplifier would have been just standard parts, right? Yeah.
Yeah, the MUX we got from where I work, and the amplifier we borrowed from Smart Optics.
All right, well, thank you again. We have a small present for you, as always.
Thank you all.
And then there is one more presentation before lunch. And it's going to be a very interesting one because this will tell you how to automate your network using InfraHub and Terraform. And yeah, why is that interesting? Well, because if you automate it, you don't have to do it yourself anymore. It's very simple. Here to tell us all about it is Marco Martinez.
Yeah, thank you. So I guess everybody looks hungry, so I'll try to hurry up a little bit. I might ruin some weekends here because people want to automate their stuff at home. Well, I'm sorry. So first about me. My name is Marco Martinez. I work at Swisscom. I'm an infrastructure automation architect. And if you want to connect or have some questions about my work, feel free to contact me. So what are the challenges in network automation? We have the big challenge that our configurations are sometimes stored in Gits, sometimes stored in other files, maybe sometimes they're not stored anywhere. Any hands? Very good. I didn't see any hands for the record. Then we also have the problem that our information is split into different domains. The network engineer wants to get it working. The security guy wants to have it secure. Somebody maybe just has some other organizational requirements. And we need to get this into one domain where we can make it work and we can make it sustainable. Sometimes we have a lot of steps that we need to do to apply a config. We have different reviews. We have different CLIs we need to open. We sometimes have to go on each device. So we try to do it the most efficient way we can. Then a big problem for all of us is the drift. So we have out of sync. When we have an issue, sometimes we don't adjust the desired state. We just go onto the device, we fix it, and we go in our weekend. But do we really want that? On Monday, if somebody does a rollback of the configuration, will it still work? Probably not. So the common challenges I identified is the delay that we have, getting it from our heads into the devices. We have the config drifts. Sometimes humans make errors. And also the visibility sometimes is not great, since we just go onto the devices and fix everything. So I think everybody's a little fed up with the concept of source of truth. That's why I added another word. I call it the living source of truth, because the idea is here, our source of truth is actually the truth, and it's something that evolves over time. So we don't do it once, we do it multiple times. And if we want to adjust something, we adjust our source of truth, and that should adjust our infrastructure. So the management can be over UI, it can be over code, or it can be anyhow we can imagine it. We want immediate consistency. So if we change something, the source of truth, it should automatically change on the devices themselves. Or if we adjust it on the devices, we can also sync it back to the source of truth. That's also an approach I would say is okay for me, but I like the prior one where we do it on the source of truth and then we immediately sync it back to our devices. Then we want faster feedback loops. So if we want to adjust something, maybe you have filters in our source of truth. You cannot set this IP, that doesn't belong to us. This filter list needs to be applied. So we can also do that in the data model, and we don't need to do that on the device. Yeah, I, in general, don't like manual steps. That's why I do automation, and that's what I also want to see less of. Then, in general, we want transparency. So let's start our journey. first of all, our goal is to manage our infrastructure reliable, and we do it in a stable way. So infrastructure as code might seem like a good fit. It has a lot of good things in it. It is the logical thing we think about if we want it reliable, we want it reproducible and stable. But sometimes it also has a continuity problem where we just do fire and forget. We do this Terraform command and it's gone. Maybe we lose the state file and then we don't really have an idea. Or even worse, we use like 10 tools and we don't really know which tool belongs to which domain, and it just is a huge mess. Also, the problem of using many different tools is that we have a problem of complexity. Our environment is very complex. Somebody asks me, oh, how do I adjust this router? And I'm like, go see in the Git. That's an approach, but if I use different automation tools for everything, I'd rather not have it in the Git. I'd rather have it somewhere where I can do it tool agnostic, and then the tool does the job for me. Yes. So, but at the same time, we all know money is a precious resource, time, the same thing. So we have to do it in an agnostic way where we bundle the complexity in one place, and then every tool does what it does best. So in this case, I don't try to automate a firewall using PowerShell. Maybe sometimes I do, but usually I don't. So I try to define a desired state. Then I aggregate these desired states in my data source, called the living source of truth. And then I create my infrastructure with the tool that is the best fit for this task. So this is a little way how you could do it. So on the left-hand side, you can see you have your infrastructure as code tools. And those are not modifying our infrastructure in the first step. They're just modifying our source of truth. So I can go onto the source of truth. Here it's an InfraHub, where I can either go onto the web UI, I can do some modifications, or I just use Terraform and I'm like, I want to have 20 new routers. So I just spin up 20 new routers, put it in my source of truth, and then the source of truth has hooks that then does it on the actual infrastructure. So here, I don't need to use Terraform, I can use Ansible, and for the source of truth, I could also use Netbox. It's just a way of stitching the thing together. Then on the right-hand side, I see here I have my tools that fit best my environment, what I want to do. So here I can see I have SDCIO, that's schema-driven configuration. Here, this tool does all the work for me. I have the schema ready in my data source, and then I push it to the SDC, and this one does all the magic for me. It does all the configuration, and I don't need to ask about what is done. So what I see in the source of truth is the actual reality. Now I prepared a little deep dive on how we can do a setup like this, and I would like to take you on the journey with me. So first of all, we have this version-controlled system that is InfraHub, where we can have governance on it. We have different branches. We have this model where we can use exactly what we want. We're not cornered into using something that is suboptimal. We just adjust it. So on the left-hand side, you see my Terraform code. I have a new spine leaf architecture that I want to build. This is a small snippet of it. I just create a few spines, a few leaves, and then push it into InfraHub. So on my next step, I can see the main branch, and I'll comment the video as it runs. Let's see. Yeah, I go ahead. I create a branch that is brand new. Let's call it LAN refresh because I'm doing some new stuff. Of course, this branch is empty now. It's the same state as my main file. I scroll through the Terraform. This is all I want to do. These are all my new switches. I have some management IPs, some interface statuses. I apply this, and what this does, it hooks into InfraHub, and it creates all my devices. So now on the LAN refresh branch, I have all my devices I want. Now I can do the 4 eyes principle, and I can tell a colleague, can you check, are these devices the way we want them to be? Do we need to adjust something, or what do we do? If my colleague says, oh, maybe that is supposed to be different, then we change it, right? We do it before we're changing stuff in production. We change it before that. We can have automatic testing as well. We can have the security guy doing his eyes. And we can do all of it. So here we can also see the diff about it, and we can merge it. So now that we're going on the journey with us, I also have this nice dashboard. It has live metrics on it, and also the green slots you can see, those are the connections, and once I put them down, they're going into red. So that we'll see in a later stuff. As a disclaimer, this is not a real network, it's just a container lab, but it should simulate a real network. Nice. So what we have right now, we have our data in the source of truth in InfraHub, and what we built now is the right-hand side, which is running on a Kubernetes cluster. And that one, there's an operator that pulls our artifacts from InfraHub, and then the artifacts actually configure SDC. SDC is Kubernetes native, and the custom resources define what SDC is doing, and then it defines the network itself. So what we do, this is my config artifact. It is just a Jinja template, and it's the Jinja template that I built beforehand. This is for all my devices. I can do this differently for every device I want. And then it automatically generates this for every single device I put in this group. So here I have my Nokia devices, and it will put, based on the information I have in my source of truth, it will generate these custom resources. Yeah. What this Vidra does is it takes those artifacts, it downloads them, and it applies them to Kubernetes automatically. So if I change something in Kubernetes, it will directly apply them. If I change something in my source of truth, it will automatically override it and apply it to Kubernetes. So this is how I can ensure my desired state is always the state that is on Kubernetes and the state on my network. Good. So let's go through that. On the right-hand side, we can see the thing. Everything is up. We do a new branch. I decide I want to change something in my network. I want to disable some. I want to do some maintenance. So I call the branch maintenance. What I do next is I go into my source of truth, or no, actually I go into my Terraform code. I adjust the branch I want to work on, and I say, oh, maintenance, I'm going to take down some interfaces of my spines. So what I do there is I go into the interface. I do this, the enabled value is false now. And next thing I do is I push it onto InfraHub, or I do a Terraform apply. So what this does is it changes it in the data, in the data source in my InfraHub. I can go onto the branch now and check if there were any things made, if there are any changes on there. So in the maintenance branch, I can do the governance step now. The security guy can do his eyes. Everybody can look at the changes if they're fine, and then we can merge them. Now we go check the diff on the branch and see what was changed. So right now is maybe a little small. Maybe the people need to take out the reading glasses, but you can see that all the interfaces changed their status from enabled to enabled false, which is disabled. Yes. So the cool thing what InfraHub does is now that I merge it into my main branch, it also regenerates the artifacts. Now on the side, we can see very small that the status from enabled changed to disabled. And once I merge it into main, my Vidra operator will take it, put it onto the Kubernetes cluster, apply it, and SDC will push it to my devices. So right now it's merging. This is all in real time, by the way. This is not sped up or anything. So I can go here, check my main branch, go back into my Kubernetes cluster. I just open the thing I showed before. Now we can still see it's still enabled, which it usually takes a couple of seconds. Once I run the command again, it will be on the status disabled, just we have in the source of truth. And then it will take, SDC will take it immediately and apply the config diff to to the device and will take down the interfaces. So now we can see all my spine interfaces, or the ones I configured, the first 3, are already down, and that's how it is in my source of truth. Some people might ask me, what do I do if somebody calls me at night? Yeah, my boss tells me, fix it. Well, the problem is, if I do the old school approach and just go onto the device, it will work for a few minutes. Will it work after that? We see. So here, my boss calls me at night. I don't like it at all. I'm too lazy. I'm like, this source of truth, that doesn't do anything. Let me go on my spine. So I go onto the interface. I see, yeah, it's disabled. Obviously, it can't work like this. So my first intuition is, I go into the config, I'll change it real quick, and I go back to sleep. Well, if you have the dashboard, the good thing is you can see your changes do something. So right now, I apply the changes, and my dashboard goes green in a few seconds, I would assume. Yeah. But that's obviously not the approach how we want to work, because now we have identified a config drift. So we saw they turn green right now. I put the interface on the first switch I enabled, and it works. Now I can see on the SDC, I go back into the config artifact. It hasn't changed. So we're still in the disabled mode. But that's not good. Now we have the config drift, and now we can see SDC is the bad guy, and it just overrides it, what I did. So all my work is gone, and my boss will call in 5 minutes again. So what you should do now is, maybe you're tired at night, you don't want to do this Terraform stuff, you don't want to figure out where it is in the code. So a good thing would be, yeah, just do it in the UI. Sometimes we're tired, sometimes we don't want to figure out code. We go into the UI, we put the tick in enabled, we push it to the main branch. Maybe somebody watches. Where's the security guy? So we can see the artifact was regenerated. Now it puts it onto enabled. Once I merge it, it will instantly take up the interface, and I hope the problem is solved by now. So that is the really easy approach on how to do it. It doesn't require big coding skills. It just does it automatically, takes care of stuff. And the nice thing about this is you don't need to see your network. You can have your observability still. But you still have the source of truth where you see the desired state, and hopefully those two things match. Right. We can see here, it already applied it, and now it should also go red in a couple of seconds. Let's hope it works. Well, oh, no, I enabled it using the config, so it will not go red. Thank you for paying attention. Well, so that is the whole model of it doing. Somebody might ask, but what if I do other things than network? Good question. What if I have other tools? Where's my observability? Where's all my other stuff? So the living source of truth is not just I configure my network, is I configure everything. Could you imagine having all your data source of your network in your source of truth? You could configure your monitoring tools. If you add a switch, you don't need to configure your monitoring tools. You just pull the data from your source of truth, and you know what to do. Maybe your Cisco switches always need to monitor your CPU load, maybe your interfaces, maybe something else. Also, you're not bound to this SDC tool. You can use your Python tool. You just pull the desired state, and you apply it. You can do pipelines. You can still use Ansible. You can do whatever you want. This also could apply to DNS. I have a talk in my pipeline that I do power DNS, and I want to configure it using the source of truth. So if I change something in the source of truth, maybe it applies it onto the DNS. But that's a topic for another time. Good. Some might ask, well, I already have a network. I already have my automation tools. How do I get from point A to point B? Well, in my opinion, start small, have data sources, maybe try to centralize them as much as possible. If it's not possible to do it in one place, just sync them. And usually, I would fix the most time-consuming issues first. If I take 8 hours to deploy a new switch, maybe I should start there. Like, taking up an interface, taking it down is not that much of work. But yeah. Also, use the tools that fit your workflow best. So I would not use PowerShell to configure a Cisco device. But maybe I would use Ansible, or maybe even Terraform in the new world. Or maybe this SDC tool also comes in handy. Yeah. So obviously, everybody has their tools. Work to your advantages, and automate the things you can, and also accept if you cannot automate some things. Some things are just a requirement, and we have to live with it. Next up, my goal, how I view the world, is I want infrastructure that I can change however I want. I don't want infrastructure that is on the device itself and the device is the source of truth. I want to be able to push my new config onto the device and just delete everything that was there before that. I want to have this central data source that does it all for me, and I don't need to check on the device and fear that somebody made a change yesterday at night. Also, what I think having a data source or multiple data sources that sync is it generates a lot of transparency. Maybe we have some less technical folks that also want to see where is that IP, what is the progress of our project. I saw a Grafana dashboard today, or somebody mentioned it. That is quite a nice way of doing that. So they don't have to ask an engineer. They can go onto the source of truth and just check. Also, a nice thing would be if we didn't, well, maybe some people will hate me after that, but it would be nice that we cannot log into our devices from a security point of view. If just InfraHub pushes our data to the tool that is needed, and the tool does the thing. So nobody can log into the device. Maybe we have a break glass user that we never use, but we don't need to log into our devices. I hope I can still walk after this, and nobody hates me. And also, I think it's nice having this single pane of glass where I can see what the actual status is, and not have to fear that it's different every way. Everybody knows this guy that says something in the meeting, and somebody's like, actually, that's not true on this device. I don't want that. Yes. So the whole demo I have is on the GitHub, and I would like to open it for questions.
Thank you, Marco. Fortunately, there are questions. Again, I have a feeling that one will be about DNS.
It won't.
We will see.
I hope
Peter.
so.
It won't. So, hi, I'm Peter from PowerDNS. I'm the other Peter. Does InfraHub and Kubernetes run on infrastructure it manages? And if so, can you do a cold start?
On my proof of concept, it does.
I'm talking about your production environment.
Oh, my production environment? No, it doesn't. So we have our data source in one place, and we have the infrastructure it manages in another place. So we kind of don't have this chicken and egg situation. But it could definitely be an approach that you're going, but I don't see it as realistic right now. It would take a lot of engineering effort, and we only have so much time and budget to do it.
All right, thank you.
You're welcome.
Hi, Joris Klaassen, Risk Networks. So very familiar problems that you're solving. Good to see this working. I was curious, when an operator fixes something at night using InfraHub, how does this thing sync back to your infrastructure as code within Terraform?
Well, in Terraform, it's just a vehicle to change what is in InfraHub. Right. So ideally, I wrote the Terraform provider, so it's not working yet, but there's a Terraform import that would import the data you have in InfraHub, and then you can change it there.
Exactly, yeah. This was the part that was missing. Thanks.
Bart Dorland, self-employed. Thank you, Joris, for taking my question. So I was indeed wondering how you would deal with, not everybody is as good with Git or with Terraform, right? So my question was around the state that Terraform keeps, right? And if you make changes in InfraHub, you might have challenges around that. But we'll save that. So then, for next year when you're coming back, right? Can you do a comparison of what you built and then put it against CubeNet?
You mean the custom resources?
No, the whole thing, just against CubeNet of what they are doing with Nokia, right? I'm sure.
Well, SDC is part of CubeNet, right?
Sure.
Yeah. I can do that, yeah.
Yeah.
I'll hook you up with that.
Yeah, sure, great. And else we'll just include Urs and we'll fix everything, right?
Yeah, sure. We'll also use some nuts.
For sure. Thank you.
Thank you very much again, Marco. And please wait. We have a present for you. All right, that's one sporty chairman. That brings us to the next topic of the day, which is lunch. Stop. There are a few points here. Some of you have entered dietary requirements when you got your ticket. The good news is that for lunch, everybody can have everything, except if you are the one person who asked for a gluten and dairy-free menu. That person can report at the bar, and the rest can all have everything that they want. After lunch, I will hand over the host microphone to my buddy and internet god and blah, 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 Nick. So I say thank you already. Enjoy your lunch and see you after that.
Hallo.
Kun je überhaupt... Ja, dat kun je zien vandaag.
Ik zie de timer.
Het is tot einde presentatie, dus de vraag is, hoef je daar niet in. Dus je kunt helemaal tot 0 door.
Dat is mooi, want ik heb 49 slides.
Dat weet ik. Die zijn
misschien ik denk dat het kan. En anders jaag ik hem een beetje op.
Vanwege de setup kunnen we dus niet de slides hierop zien.
Oh, dat is onhandig, want ik zie mijn slides dus niet.
Precies.
Moet die monitor daar, want dan moeten we dit... want ik kan niks zien. Dan moet ik iets opzij gaan zetten. Slide.
Nou, dan komt het goed, toch?
Ja.
Oh, dat snoer is niet lang. Nee, okay.
Nee, dit werkt.
Mooi.
All right. Welcome back, everyone. I hope you all had a nice lunch. I certainly enjoyed mine. Thank you, thank you. Everyone that was on the waiting list and did get a chance to pick up a t-shirt, we have enough, so go by the entrance and pick up a nice t-shirt for yourself. Next up, we have a talk from Sasha. She's going to talk about the how and why of Internet.nl. And Internet.nl, you guys may know from emails you got from customers complaining about bad scores on Internet.nl, or maybe you find it a very useful tool. However you view Internet.nl, we're going to hear all about it. So Sasha, take it away.
Thank you. So my name is Sasha. First, I'm wondering who knows Internet.nl? Oh, that's pretty good, pretty good. And so in preparation for this talk, I decided to look through the archives that I have of the NLNOG chat channel and find any mentions of Internet.nl and use that as sort of a guidance to figure out what I should be talking about, such as, I kept the original quotes in Dutch, Internet.nl generates such a headache because they don't know how the real world works. I intentionally left names of this slide, the same person was a lot more positive about us later, and also other people have also said very good things about us. And so I thought it would be nice to come and talk about some of the things we do and how and why. So my name is Sasha. I'm an independent developer. I do a lot of work in internet routing standards, infrastructure. You might know me from IRD or IRR Explorer. If you use the IRR, you use my code. I also am an open source working group coach in RIPE. I have a lot of different hobbies and a personal ASN, of course. I've been a contractor for Internet.nl since 2022. I do not work for the government. We're a government-affiliated project a little, but we are a bit more broad than that. Internet.nl is run by the Dutch Internet Standards Platform. It is a collaboration of governmental, non-governmental organizations, also representatives of commercial organizations like the Dutch Standards Board, Forum Standaardisatie, but also SIDN, SURF, and a number of other organizations. And our goal is to increase the use of modern internet standards to make the internet safer, accessible, and more reliable for everyone. We do this in the form of meetings that we do with all of these organizations periodically, where we do talks about the internet. But also, one of the things we do there, mostly coming from Forum Standaardisatie and external people like myself, is Internet.nl, and we are a standards compliancy testing tool. We are notably not a security test, a common confusion sometimes caused by ourselves. Many of the things we test relate to security, but it is not our goal in itself. If you score poorly, it does not mean you're insecure. If you score well, it does not mean you're secure. We test web servers, mail servers, and client connections. Last year, we ran 1 million tests on NL, which is our interactive website. And also, we run a dashboard with an API for a select group, including government organizations. And we've done 8 million tests there last year. So there's a lot of long list of domains that people run through this periodically. All of our work is open source. Recently, we improved the deployment a lot. Now it takes an hour, not a week. So for people who want to run mass-scale testing, they can run it on their own. And several of them do. There's also some international reuse with different translations, sometimes different standards. And this is also used for things, reporting from the government about the government itself, such as this bi-yearly report about standards compliance by the government, where you can see that some ministries are much better at IPv6 deployment than others, Ministry of Defense at the end there, but also different types of government organizations. There is a huge report, and everything is public. SURF does some of this reporting internally for universities and higher education. And there's also, I entirely forgot what this thing is called. There's a list of domains run by the national government that they publish, over 1,000 of them, and they also run all of those through all the tests from NL. So this is also all public info, and all of this is based on the standards that we built. And then there's all the internal reporting that a number of organizations do. And I always enjoy seeing actual impact from this. Like when we added RPKI a while ago, someone said, do you also see all your customers asking how to make ROAS for all their own space now that NL complains? This is, to me, things that this project is about, like stimulating this kind of development by, we have a very broad target group of people that look at that use our tool, that look at it. And that it's good to see that sometimes this has actual impact. This one I'll translate. The only time my current client said IPv6 was in a ticket that said we have to score 100% on NL, and it says we have to do IPv6 DNS. And I think that's great, because maybe these people wouldn't have cared about it otherwise, but because it's part of our testing tool, we are stimulating the adoption of, well, I was going to say modern standards, but IPv6, I don't know if we can still call it modern. So we test a few different categories, IPv6, DNSSEC, HTTPS, HTTP security headers, and security TXT. For email, DMARC, DKIM, SPF, StarTLS, DANE, and RPKI. Some of these are more well-known here, and I will not go too much in detail, but I'll go into some of the lesser-known ones in a bit as well. But, of course, a big question is, what do we actually test, and how do we set these criteria? So let's do a little crowdsourcing. We're going to simplify to good or bad. We actually have 4 different levels for how we assess things, but we're going to keep it simple. Let's say a domain has 3 name servers. 2 of those have an IPv6 address. 1 of those IPv6 addresses is unreachable. Who thinks this is good? IPv6 domain? No one, very good, yes. Definitely not okay. Let's change it a little. Both of them work, but they only respond over TCP to DNS queries. Who thinks we should say good? Oh, I think we need to change this test. We can only say good. We don't distinguish UDP, TCP, either of those is good enough for us. Should we? I'm not sure. If you have strong feelings, we should only flag them if it's UDP, then let's talk later. Let's do a different one. HTTPS with TLS 1.2 configured with TLS, ECDHE, ECDSA, AES 128, CCM 8. Who thinks, yeah, this is fine? Who thinks, no, not okay? This is bad. Almost all of this is good. CCM 8 is even for quite a while not okay. It's a good mode, but CCM 8 compared to CCM has a truncation in one of the authentication tags. I don't even know why this exists. Let's do another one. TLS 1.1 with TLS DHC RSA triple dash ED CPC SHA. Who thinks this is bad? It's actually okay currently. It's actually okay. This is not my decision, but soon this will change. In the next few months, basically all of the words in this will be flagged as not okay. And how did that happen? Oh, we're going to do another one. A web server IP is covered by one BGP announcement. There is no ROA. Who thinks this is bad? Bad? Yeah, okay. More complicated. There's two BGP announcements. One has a ROA. It's the more specific one. The less specific one does not have a ROA. Who thinks this is still fine? This is covered by IPKI. Some fine. We currently say not okay. Some people do this, and none of them have been willing to tell us why. I do not understand. We only talk to them through clients. So if you do this and you have a reason, then I want to talk to you later. But basically how we, who decides what to test? We look at ideally clear consensus, existing normative references, and there is also some degree of local bias in this. We do not actually make them up by crowds by polling a few people. I don't make them up myself. So some things we look at are RFCs and best current practices coming out of ITF, CA browser forum guidelines. A big one is forum standaardisatie, which makes or guides two resources, which is the comply or explain list, pas toe of leg uit, which is a requirement for governments, mostly for newer projects, or streefbeeldafspraken, which I cannot translate. Which is should also, it's a bigger deal. It should be applied to, there are standards that should apply to everything the government does. The Dutch National Cybersecurity Center, there's a little bit of legislation also. HTTPS is actually required by law for the government since a while for most government websites, also to a certain standard. And there's also a bit of industry convention. If we know Firefox and Chrome both do a thing a certain way, then that is sort of the standard already. But none of these are necessarily defining on their own. And of course, something has to be possible to test, to be able to test remotely and in reasonable time and without having special privileges, without hurting the target we're testing, and consistent most of the time. Some tests, you cannot get all of these 100% of the time, particularly the consistency. We don't harm our test targets. So as an example, all of our TLS standards, if you're wondering why is triple dash still allowed, in 2021, the NCSC thought, yes, this is still allowed, but they've recently published a new standard, better standard, poorer design, which is also based on BCP 195, which is consists of two RFCs regarding new TLS standards, but also recommendations from the CA browser forum and existing work from similar NCSCs from a lot of other countries, which I'm listing out to show that there's a lot of work that goes underneath this before we say no more triple dash. It's not just me. There's a lot of work in figuring out what should the standard be and building consensus for that and finding what are the actual realistic practices, both in the Netherlands but also beyond. I'll translate this one first. Someone said it's one of the latest internet NL fads. Green check marks, DNSSEC, DANE, SPT, DKIM, and DMARC. And I thought I should maybe highlight some of those standards a bit more because they're not as well known in this community. I assume they meant SPF. There's no SPT. They're also not actually our FATs or latest DNSSEC, which I think is pretty well known, is from 2005, at least some of it. This isn't so controversial anymore. Some people don't like DNSSEC. I cannot help you with that. But it is very widely supported, but there's a lot of ways to misconfigure it. We don't even detect all of them. We do try to check the whole chain down to also other domains. But a lot of what we see here is misconfiguration or incomplete configuration. SPF and DKIM are email standards that allow you to figure out whether an email is authentic from a certain domain. SPF says which hosts can send an email through a DNS record. There's a lookup limit, more on that later. And DKIM does email signatures. So when you receive an email, it contains a signature header. You can look up a public key in DNS based on that and use that to validate whether the person who runs the DNS is okay with this email being sent in this way. For DKIM, we have to work around a little because DKIM uses random selectors so that you can have multiple keys at the same time active. We don't know your selectors. We don't have your email. So we use, as a trick, we request the domain key record under your domain and check if the response is NX domain or no error. If it's NX domain, we know you have no DKIM records. If it's no error, we know there's something. We still don't know if it's valid, but it's the best we can do remotely. And DMARC builds on top of these two, which tells other mail servers what to actually do with your email. And also can report on it. So let's say SPF fails or DKIM is not valid, then it tells the mail server to maybe reject the email, and you can do a lot of interesting reporting on this. So these are things we are pushing also for email, for authentication. As I'm sure you're aware, phishing is a huge deal. Let's do a good or bad. How about this form of reporting? Who thinks we should approve this DMARC record? It's wrong, but not for the reason you might think. My opinion is that you're allowed to use FTP URLs. Most DMARC checker tools will actually choke on this. We don't. We allow this, and we should. But DMARC, you can configure DMARC and just say the policy is none on the first line. So sometimes it's not just creating a record, but also having it restrictive enough, which is also something we check. And finally, Dane. Dane basically lets you say in DNS, you should expect these TLS certificates when you connect here. In web, people don't use this a lot, but in email, this is a huge deal because it prevents stripping TLS in between. Web browsers have become very good at being annoying about plain HTTP sites. On email, we don't have that. If there's a person in the middle, they can stop TLS negotiation, and Dane is one of the ways you prevent that. So that's why we have these. Also recently new and raised some questions was CAA, which said you restrict issue of certificates to a limited set of CAs or none. Those two CAA records were not there when I mailed RIPE-NCC through their bug bounty a few months ago. So it allows you to restrict who can receive certificates under your what CAs can issue certificates, or even say you can't issue any. And finally, the HTTP security headers. There's a number of them. Also, this is not an HTTP group, so maybe not so well known. Content security policy restricts what type of content can be loaded from where, such as inline JavaScript, you would usually disable. So this is complicated sometimes, but also very powerful. Recently, a CSP could have prevented a partial RIPE database authentication compromise, I found. So it is a very powerful security measure. Refer policy is also a privacy and security measure that restricts refer headers passed through browsers. Security TXT, I think more people here have been adopting, which has security contact info, which can be hard to find. And finally, there's two somewhat older headers that also deal with various browser exploits. And these are also all recommended, so they don't have a score impact currently, and maybe they won't. When we deal with these standards, you think, oh, a standard, oh, an RFC, that'll be very clear. We can just implement that deterministically and say you comply, you don't comply. Unfortunately, not always. Last year, we put a lot of work into security TXT and raised the question, how do we interpret the field canonical? And the author said it is vague intentionally. Someone wrote a standard and said it is vague intentionally. I spent hours in meetings figuring out how we should validate this field until something was chosen. So yeah, this happens. CAA does, this was my last thing I implemented, so it's fresh in my head. CAA lets you specify reporting if someone requests a certificate, and CAA says no, you cannot. You can report on HTTP or HTTPS, but you can only do it using a protocol that itself says you can only report over TLS. So can you do HTTP? Can you only do HTTPS? I don't know. The standard doesn't know. I currently say no. I say it has to be TLS. Maybe someday someone will email us and complain, and we'll adjust. And earlier I mentioned SPF. SPF has a lookup limit. Almost all implementations of the lookup limit are wrong. So you can refer to you can include other people's SPF records. The lookup limit is really complicated for some reason. I did not write it. Our current implementation still has an off by 1 error. I fixed the last one. So we had an off by 2 error. Now we have an off by 1 error in some very obscure cases. We're going to fix this by integrating someone else's tool, by people who did a lot of hard work to figure this out. This is something I've been working on more lately, is having less code. Sometimes people think my job is to write code. It's actually, I prefer us to not have code and to defer more to other existing tools and potentially build on those. So some of our big challenges that we are into, many standards, as I just showed, have rough edges. There are many implementations, both in testing tools and production systems, that are slightly wrong. And also people do very strange things on the internet sometimes. As we make new releases, we check a lot of domains against the current production system and a new one to see, are there unanticipated score changes? But also, what kind of weird things are people returning to us in DNS queries that we may not have anticipated? And also, we have a huge background of people that we communicate to. I think our documentation on our text on the website is about 50,000 words. And we're trying to address anyone from the people in this room, but also people more at CEO level. And we try to give them all enough to go on. And also some standards are just much harder to test than others. Things like RPKI, DNSSEC, they're just like, you just run a DNS query, you just look up some basic data there. They're easy to test. TLS is a lot harder already. Email TLS is a nightmare. Because, and DKIM is a little tricky because you can't access the full record. But TLS, which is one of our bigger tests, has no way to tell you what the config is. How do you figure out if a server supports TLS 1.2? You make a connection with TLS 1.2, and maybe you have a connection, and maybe you don't. And then you probably know they don't or do support that. You can do this on web servers pretty easy. They're very tolerant of this. We make a lot of connections. They're fine with it. Mail servers do not like people making a lot of connections very rapidly, many of which look very weird. So I feel like half the tickets that get escalated to me are about my mail server won't get through your TLS test, and I've developed a standard way of dealing with them, which is that the stronger someone denies that they do rate limiting, the higher the chance that they are absolutely doing something, and it's usually the most bizarre thing also. I've had people complain that their domain didn't pass, and it's like, every connection we open, you make us wait for 30 seconds. Like, we only have like a few minutes to run the test, which is fine. You're allowed to do this, but it's not going to be testable in our tool. Also, all of our work is open source. We try to give back to others as well, contribute. Our goal is not just the tool itself, but also the promotion of internet standards aligning with our goals. Recently, I found something sometimes you find very obscure stuff. There's some obscure rule in CA browser forum rules around root certificates and whether the I don't even remember all the words. The authority cert issuer has a certain field, and apparently no one found this bug for years until I tried to integrate an InternetNL. Got my first commit in OpenSSL, which was 1 byte, with some API that I think almost no one uses. But also we do bigger things. We started writing all of our TLS code to use standard Python testing tooling that is NASL and SSLize. And so I've been contributing to those a lot to get them to meet our standards, but also not have me maintain all of our TLS code and allow other people to reuse the work that we do. We are also not trying to be certain other tools like DNSVis, ZoneMaster, IR Explorer, email security scans, SSL labs. We have some overlap with some of these. but they tend to go much deeper into one specific field, which is great. We refer to them a lot. We cross-check. Sometimes if there's inconsistent results, it shows a mistake on our side, sometimes on someone else's side. Sometimes, actually, every other tool is wrong, and I was right. But also we refer to people to this to dive a little deeper into things. Occasionally, people express that they are not fond of our test store criteria, which is also why I showed you a little of how we define those criteria. But also, this is not actually a mandatory testing tool for anyone, except some scenarios where for government organizations, or if you work for those, some of it may be required. That said, we do really appreciate feedback. We have question at internet.nl. There's also me. There's also Benjamin running around somewhere who conveniently I've lost track of, wearing, in the back, wearing an internet.nl shirt. So we do actually like hearing from you, but it has to be a little substantiated with some views and references, ideally. Also, if you think we're drawing the wrong conclusion, that sounds like a potential bug. But if you think, no, you should evaluate this DNSSEC configuration entirely different, we are happy to hear and adjust. We frequently adjust, especially weird edge cases, based on feedback. But if you're just like, oh, I don't like V6, I don't think you should be testing for it, then I cannot help you with that. There is the one critique I've heard a few times is that we draw people to focus on some specific areas that we currently have good tests for. Personally, if I could choose between the entire government scoring 100% but running on a single big cloud, Microsoft, versus some minor issues, I would rather have the latter, where maybe they don't score quite as well, but at least there's more independence. So this is one of the things that I'd like us to see addressed in the future. We're also working on a design refresh. It currently looks very 2000s. I have not included any screenshots, I realized, but it's definitely, if you think like, oh, this is a website from the 2000s, you're on the right website. But we're fixing that. And also I've been working on a lot of technical debt. I've deleted a lot of our TLS code and replaced it with external tooling. But also I want to do better database design. I want us to give back more debugging info. Currently there's just too many questions that I have to manually dig into, when it's like, we could have had that info already. We know if your mail server sends a 451 that you're rate limiting us, but we currently don't tell you well. And also what I just mentioned about data locality, independence, sovereignty is something that I'd really like to see us test more for. And finally, the scoring model. We currently do 0 to 100%. I feel there's more we can do there. It is not quite harsh enough, and sometimes it is a little too harsh. Something for next year, I think. So that's some of the things I would like to work on. And that's all I have. So thank you for listening.
Very much. That was really insightful, and I definitely have some questions and feature requests as well. We don't have a lot of time, so a couple of quick questions. There? You have a question? Or you just listening? I'm just listening, I guess. Are there any questions from online? All right. Then I'd like to thank you again very much, and we should speak later.
Thank you.
Dankjewel. Leuk.
Dank je.
All right. Our next speaker is Luc Hendricks. Luc is going to talk about how we can collect routing information with Rotonda. Rotonda is an application to build BGP applications. I should say framework, maybe. Well, he's the expert, so I'm going to leave it to him. Take it away.
The expert, okay. No pressure. Hi everyone, my name is Luc. I'm with NLNet Labs, and we make open source software. And I guess if you're in this room and you've heard of us, then it's either because of our DNS stuff or our routing security stuff. And most likely, if you heard of us, that's because of Routinator, our RPKI validator. And when people started using validators a couple of years ago, not necessarily Routinator, we got some worried noises from operators saying, you know, we want to do this route origin validation, but you know, making sense of our networks is already hard enough, and now there is this extra RPKI thing directly influencing the routing decisions. You know, stuff gets a little bit less tangible, a little bit more scary, if you will. We were like, yeah, you know, that sounds fair. At the same time, BMP appeared on our radar. That seemed to get some more traction, and we thought, you know, maybe we want to become an expert, and we should make something that collects routing information, also feeds in RPKI information, and while we're at it, you know, make it super flexible, and oh, it should also scale. So, you know, how hard can it be? Today I would like to present to you Rotonda. That's what came out of that crazy idea. It's not done. We're far from done. There will be rough edges, and you will see them. But at this point, I think it's very, very usable, and I hope that at the end of this presentation, you will have some creative ideas of, hey, maybe I can do this and this with Rotonda in my network to solve this and that. So, let's go. Before we dive into the components that comprise Rotonda, if I say BMP, does everybody know what I mean? Who here considers themselves somewhat familiar with, with BMP? Somewhat familiar? Anybody that uses this on a daily basis, perhaps? No? Most of you are wondering, why the hell is this guy talking about bitmaps? Yeah, okay. Okay, that's really unfortunate, because I only have a super criminally oversimplified single slide to explain BMP, which will get us through this presentation. But after the break, Thomas, is that you? Yeah? Thomas will do a proper introduction of BMP, and then he can correct me and make fun of me for 50 minutes straight. So, but for now, let's say we're AS1, and we have a BMP station, think BMP collector, configured. What will happen is whenever we get an update from our peer AS2, what goes over the TCP connection to our BMP station is basically that update, but then wrapped with some additional information. Most importantly, this per peer header that said this is an update that came from AS2. So this way, we can actually export information on all the sessions that we have on our router towards this single station over this single TCP connection. Again, this is criminally oversimplified, but for now this is good enough. If you understand that we can export loads of information this way over the single connection. Now, Rotonda. At the heart of Rotonda there is what we call the store, the Rotonda store. And this is our own in-house built, custom tailored in-memory database, which is tailored to store large amounts of keyed on prefix type information. So think unicast routes, right? And at this point, I guess it's important to notice that everything you see in the, is it dark blue for you as well? In the dark blue square is part of Rotonda, which is one single Rust binary, right? We don't rely on any external database whatsoever. This is all within our Rotonda binary. So how do we feed stuff into the store? Surprise, surprise, with BMP. We have a BMP connector, and not only will BMP give you information about all the sessions of all the peers on that router that is exporting the BMP feed, it will do so for multiple RIP views, if you will. So it can export information from your adjacent RIP in pre-local policy application, post-policy application, and the same for your adjacent RIP out, and also for lock RIP, right? And you can get this BMP stream from multiple routers, right? So this BMP ingress component is really like the fire hose of the application, if you will. Now, for those older platforms that think they speak BMP, but they don't do it, or they don't do it really well, there's also a BGP in connector, right? For us, that's really a passive component. Like we will never send out any updates. This is just a BGP session that does the bare minimal to keep the session alive, so it can ingest updates, and with that monitor the router that you connect this way, right? So this is really a poor man's BMP, if you will. And then, and that might be less interesting for most of you here, you can also feed in routing data from MRT files. If you're a student, researcher, this might be interesting for you. And we use it for testing. Then, getting stuff out, surprise, surprise. JSON, many gigabytes of JSON. If you want it, you can get them here. And another way to get data out is either via MQTT or write to a file. So these are basically all the components. And as you can see, they're a bit awkwardly positioned on the slide. And that's not because I've been using LibreOffice, because that actually works very fine. I can actually recommend it. It's because we're missing one key piece here still. And that is Roto. And Roto is our own in-house developed programming language that we use for the filters. And now, at least some of you are going like, oh. So, they took like 3 of the most popular scripting languages, took the syntax, meshed it together. It was like the shitty DSL that came out of it with its own peculiarities, right? It doesn't work at all, and they smacked a nice logo on it, and now he's gonna act all cool about their programming language, right? Well, no worries, because we don't have a logo. And I'm actually not sure why we still don't have a logo, because I think we've earned it by now. But that's something that we'll work on, so next time we'll have it. But now I will then start acting all smug about Roto, because it's actually pretty cool. So, it does indeed look a lot like scripting languages that we all know, right? I guess all of you in the room, if you see this snippet of code, regardless what it actually does, you can make sense of it, right? And that's what we're after. We're after a high-level feel to give you all the flexibility and also the performance, but I will get to that. And I was only half joking about, you know, half-assing multiple language into a quarter-assed one. We do realize that we're, you know, pushing yet another language onto people, which comes with a cognitive burden. So we want to make it as easy as possible to start using this, right? And we want to make the experience as nice as possible. So syntax highlighting is one of these things, in addition to, you know, having this high-level feel. But we can actually do something far, far fancier here. Roto is strongly typed. So if you're making a mistake like I did on this slide, if you look at the second line there, instead of an ASN, I accidentally put in a prefix, right? It would be very annoying if this is triggered at runtime while you're trying to, you know, look into a packet, and this doesn't work and you get an error. Instead, we can actually, before you start the entire thing, type check this before we compile it and tell you, wait, we want an ASN here, but you gave us a prefix. And we even have the curved lines, you see? That's very fancy. That's better than a logo. So after the type checking, and after preventing all these mistakes, Roto gets compiled. And we're leveraging this thing called CraneLift, which is a compiler backend in Rust, which then eventually let us compile the stuff to native machine code. So now we have something that is super high level, gives you the high level feel, gives you all these tools and handles to, you know, work with it in a nice way, get you all these actual proper error messages, and eventually compiles into something that's supposed to be fast, right? And with this, we can do a lot of cool stuff. Because now we can give you the tools to become very flexible in all these parts where you see the little cogs at almost zero overhead, like compared to if we would have to implement the same logic hard-coded in Rust for you, right? There's almost zero overhead compared to that. So let's see how we can then use it. So I'm highlighting the two of the ingress components here, so the BMP and the BGP one. And these are the examples that I think we actually package in the releases. As you can see here, the type system helps you reason about the filters that you can write, right? For the BMP filter, you actually have to work with this thing called the BMP message. You get the entire message that you can look into, that you can log on certain things you want to log on, send out events, whatever. For the BGP one, it's the BGP message. And although I said they are very, very similar in the oversimplified BMP 101 slide, they are actually different, and this allows us to give some extra handles, for example, on this BMP message, right? And if you make a mistake, the type checker will get that for you before you actually spin up the application. So for example, in BMP, we have multiple message types. One of them is peer down. It says, your session with this and this peer has gone down, right? Such a thing does not exist in that sense in BGP, so you can't do that in the BGP filter, but you can do that in the BMP filter. And if you can read it, the contrast might be a bit nasty. Things like check for ASs in AS paths, you can do that on both of the message types. Check for whether a community is part of the message, you can do that in both of the, on both of the message types. So those are some simple examples that you can use to act on the entire message, perhaps drop it if you don't want to store it, or a log if you see a certain community or a certain AS, that kind of stuff. Now, after your message has passed through these filters, it, as we call it, explodes into multiple routes, right? If you have a BGP update, it can pack 10 or 20 or 1,000 prefixes. In the BGP filter or the BMP filter, you work on the entire message. Just before the RIP, you have another filter that can act on individual routes, individual prefixes. And then you can do all kinds of other stuff. So we actually have another, let's call it a setup function that I didn't show, where you can define your own lists. For example, lists of ASNs or lists of prefixes. And in this case, we have a list called my prefixes, haha. And I want to check if stuff that comes in is actually on my list. And if it's on my list, what do I do in this case? I just send out a log thing, which will go on my MQTT bus. Now, we can do this here, because here we have access to one single prefix, right? In the BGP update, you might have 20. You don't go looking for a specific prefix in there. That's what you do here. Again, different type. It's tricky if you start out writing Roto scripts for this, but the type checker will definitely help you. Now, this is where the fun starts. We also have an RTR in component, right? Because we need this RPKI information to be fed into Rotonda. And if you look closely, you see that there's multiple new cogs here. One is near the RIP. Because when you have an RTR component configured, now, when you look at the individual route, you can call check ROV on your route. And now we can do route origin validation on every route that comes in. And the good thing is, we don't drop anything, right? We just mark something as invalid or not found or whatever, and we store it. So even if you export multiple RIP views, say adjacent RIP in free policy, and maybe you do drop invalids on your platform, then we can still see all the routes stored in Rotonda. So you still get the full view. And I will show later in a API output where this appears. But there's another place where we can now do some Roto stuff, right? Because also here, we can hook in to an event. Namely, the event that new RPKI info comes in, right? So the previous one is where a new route comes in, either via BGP or BMP, and we can call check ROV. But there's another event, which is updates from the RPKI that are processed
by your validator that produce VRPs, right, verified row payloads, that flow in via RTR. And this is another example where we use these lists of my ASNs and my prefixes. And you can, for example, log stuff that you see, right? So if you want to keep track of something that has to do with one of your ASNs, you can do that via these ways. But if you're using these two scripts now, we can actually throw in a third one for free. And this one is the actual cool one. Remember, we have the routes that come in. We do the check ROV. We have the RPKI updates that come in via RTR that are flowing through to our RIPs and get applied there. But then there is this one that actually is a callback that will be executed for every route in your RIP that was affected by the just processed RPKI update, right? So this thing gives you back something of type ROV status update, and we can bike shed that name, but this will give you the prefix that was just affected by the RPKI update. It will give you the previous ROV status, and it will give you the current ROV status. So now you can actually check on this. Like, if the status has changed, I don't care from what to what, but then I check, is the new status actually invalid? You know, I would like to know something is happening. Or maybe if this concerns one of my prefixes, I always want to send out an event, write something to my log, whatever. And this is what that looks like, and I hope, yeah, that's quite readable. So this is actually a combination of some debug output on the first 5 lines, and then 7 lines of output that came from that Roto script. Somebody created a new ROA, and all of a sudden this prefix is now covered, right? So it cannot be not found anymore in the ROV algorithm. But it's not originated by the ASN that is on that new ROA. So the new ROV status is invalid. And we don't see this one time, we actually see this for all the 7 routes that we had in our RIP at this point. So this way you can actually see how RPKI information affects stuff in your RIP, in your networks. So there. Then, how can we get data out? It's a typical JSON API. We just revamped this. You can ask information about ingresses. For us, that's like a BMP session actually describes multiple ingresses for every BGP session that is monitored, etc., etc. But the interesting stuff, I keep doing this, the interesting stuff is in the RIPs, routes, endpoints, where you can query for the prefixes stored. There's 2 variants there. The top one gives you everything in that RIP. That will really give you gigabytes of JSON. Or you can search for a specific prefix and ask for less specifics and more specifics. And the store is really tailored to do that in a very fast way. Now, on the next couple of slides, you'll see some output, which is data based on route views data. Route views is this collection project. We're collaborating with them since a couple of weeks. We have an internal BMP feed from them, which is really cool because it allows us to test and stress test Rotonda, and for them to see whether Rotonda can be helpful for them. So one of the examples from the endpoint, if you ask for a certain prefix, I think this one is ours, you'll see that if there's a hit, you will get back the prefix, and you'll get a routes thing, which is actually an array, right? Because we might have tens of entries for this prefix, adjacent RIP in pre, adjacent RIP out post, etc. And from different sessions, from different peers. And you'll see this is one that is from adjacent RIP in post. There is the RPKI status, so apparently we did the check ROV on this one. And of course you get all of the typical path attributes, right? Here you see AS path and communities. We actually store everything. So we don't strip or drop any attributes. Of course, we need filtering because this is all too much. There's your typical thingies like I want to filter on origin ASN on a community. I want to filter on the ROV status, yada, yada, yada. The most important part here is that these are all Boolean ended, if you will. We keep this thing simple. We want to give you all the flexibility, but we don't believe that an HTTP API is the right place to do that. Right? Even if we would manage to fit in all the possibilities, it will be cumbersome and error-prone. So we let you write your own endpoints using Roto again. If you say function Roto is, for example, hidden hop, like here, and you have in your Roto script the finder function, that will be called, and your result set will be filtered in that way. So this is that hidden hop thing. This is just a cooked up example. You see that the type is path attributes, so you can filter on anything in the path attributes. And if the end result of this filter is reject, it doesn't become part of the result set. If it's accept, it will be returned in the JSON response, right? Now, this is a bit verbose, and this is where things might be better in the future in Roto. But what this basically does is, I'm checking, is there an OTC, an only to customer path attribute for this route? If there is none, we reject. That's the bottom line. If we have one, we check. Is there an AS path for this route? Which in inter-domain routing, most likely there is, right? And if we have both, then we're going to do our actual check. Is the OTC in the AS path, yes or no? And if it's not, then I want to see this path. And honestly, they just thought this up. I didn't think anything of it. But does anyone want to make a guess what kind of stuff that you see if you run such a filter? Does anyone expect their network to pop up here? I know there's at least one. Who's this? Who's this? It must be criminals. Who's this? Yeah, daar. You want to make a guess? Yeah, that's your route servers. And that makes sense, right? Because this OTC thing, it's RFC 9234 with all the roles. Yeah, so you have a route server client, route server server, somebody on the path sets the OTC to their ASN, but apparently it doesn't appear on the AS path. So I guess this is some stupid trick to find, like, ARM6 route servers. If you run this over the whole set, you find other IXs as well. Anyway, that's a contrived example. The main message there is, we don't know and we don't care what you would like to query exactly right. We give you the tools and the power and the flexibility to define that for yourself. Another thing, metrics. We do the Prometheus-style metrics. We have some built-in ones. I will be honest, those are not in a great shape right now, but that doesn't matter because you can define your own using Roto. And this is one of these things that, sure, is still a bit rough, and we need to work on this, but it also works. It's available right now, and it lets you define your own custom metrics surrounded by your own logic in runtime. So let's say, and this is actually something that a operator asks us, like, I don't care about a withdrawal or a announcement. That's like baseline noise. If there's messages coming in with, say, 5 or more withdrawals in one go, packed in one update, that typically means something to me. So that's what I want to see. So that's simply solved for us now with 4 lines of Roto. We just check the number of withdrawals in one PDU. So this happens in your BMP or your BGP in filter. And if it's more than something, you just write out this metric. So this is a special thing which actually atomically keeps track of the counter. There is increase counter, there is set gauge, your typical Prometheus things, which ends up as a Roto user-defined packed withdrawals metric. So again, perhaps a silly example, maybe it doesn't apply to you, but you have the tools to customize this and leverage your monitoring and your alerting as you're using right now. So, big blank blue spot. We need to stream out at high volume. We somewhat settled for Kafka now, but if anybody has better ideas, please let us know. Concluding, with Rotonda, we're able to store loads and loads and loads and loads and loads of Unicast stuff, and you can get it out with your favorite
curl. And there is a web UI, but I'm not going to show it. Soon, we'll have non-unicast stuff. Most notably, that's VPN stuff and FlowSpec. Operators also asked us about BGP LS, which we'll look into, and everything with and without AdPath. We already collect SPA stuff. We don't expose it yet in the Roto script. We are working on persistent storage, CLI, all that kind of stuff. You can try it out. It's all open source. It's freely available. We have packages in our own repositories. There's documentation. And there's a GitHub. You know how this works. Oh yeah, and there is a release for today with all the stuff that I've presented here. And perhaps most importantly, please help us out. This is super tricky. We don't have a network. We don't have any routers. You know, the unicast stuff is available with ripe RIS, with route views, but the non-unicast stuff is actually really hard to come by. So, you know, if you can share PCAPs, maybe, you know, you can spin up a VM in your testbed. That would be great. That's super helpful for us. And please don't think that, you know, I have only a super vanilla router running a vanilla version with a vanilla BMP exporting config. There are so many edge cases in this stuff, and the BMP protocol is still evolving. It will be useful. We will hit bugs, either on our side or on your side. If you want to know more, I'm here all day. Where's Jasper? Jasper is here all day. We love to talk. If you want to know more about Roto, this is Terts. He's the guy that made Roto the magic that it is today. He's our colleague who is not here, but he will do an in-depth talk about Roto somewhere next week at Eurorust. So if you're, you know, half the compiler nerd he is, make sure that you tune into the live stream and nerd out there. That will be very interesting. And with that, I'm only 3 minutes over time, I think. And I say thank you very much.
You're perfectly on time. Excellent. We have room for some questions even. So please go ahead.
Hello, Molly Miller, Flying Circus Internet Operations. You mentioned plans to extend this for L3 VPN and BGP LS. Would there be interest in maybe extending this for EVPN and that whole bundle of complexity? Because one thing I found working with EVPN VXLAN is there's not really a lot of good tooling for getting good observability.
I think for EVPN, we actually have all the parsing stuff ready. This is mostly like gluing all the bits together. So that will be one of the things that we'll support. So, you know, to be honest, after working with anything BGP, we realized quite late in the game that, you know, this is just one big key value store, if you will. So now I think, looking at Jasper, like we rename things even in the backend to like blob to blob store, and everything is basically, you know, it can be anything. So whether that's EVPN or L3 VPN, at some point we will support that. Yes, of course we do the proper parsing and, you know, sanity checks, sure. And like again, we don't run networks, right? So we don't know what people really want. So this type of input is actually super valuable for us.
Okay.
Thank you
very much.
Next question.
Hi, Paul de Weert, Rijp NCC.
Hey, Paul.
Question, you mentioned Kafka for the streaming out. Asking for a friend. How about Kafka input?
Yeah, we should do that. We should.
Please.
We should do that. I was cleaning up the GitHub repository and I found an issue for that. That's over a year old. It is on our radar for sure. But so are many other things. So, you know, but at this point we really lack the high volume streaming out of stuff, right? Like if you accidentally, and I've done that on my laptop, accidentally ask for the entire contents of Rotonda when you are ingesting like 3 route view vantage points in JSON and you pipe it through JQ, yeah, that's no fun at all. So that's really a missing part right now, and I guess that's less so for the Kafka ingress, but it's likely we will combine those two like in one thingy thing. We're going to combine ingress and whatever that means for Kafka.
Awesome.
He is going to combine ingress and egress for Kafka.
That was Jasper.
I have never seen that man.
No,
Yeah.
I guess.
All right. I'm looking at our moderator online. Are there any online questions? All right. Please go ahead.
Yep. I guess BMP is a splendid. Sorry, thank you. Bart Dorland, self-employed. Currently at Imperva, and I implemented BMP as well. Seems like a hot topic because I was, I guess, the third one wanted to talk about BMP. Congratulations to you guys talking about it. And the next one. Nuts might be one instead of Kafka. Supposedly easier to configure and to maintain, so you could try that one. I did it with the Cloudflare package, BBMP to Kafka. They have it based on bio-routing in Go. I was wondering if you get to the actual combining all of that, I ran into database challenges, mainly because of the high volume of data and wanting to store pre and post on a service provider on 60 plus POPs with a lot of service provider connections behind that. We wanted it first all, and then we ran into challenges on the data store and querying and everything because we ran into millions and millions of entries. So heads up on that one. If you want to solve that, then you're going to want to use some kind of data lake and delayed pushing into that. Because that will be tricky. So filter where you can. So the few lines of your filter in Roto might not be sufficient to save your database on that. So that's just a heads up.
Yep. Thank you. We'll see where this goes.
Perfect. Thank you.
Thank you again, Luke, for this interesting talk. All right, next up we have Peter Foppen, which is going to help us get most out of our support contracts. So I'd like a show of hands. Who deals with support contracts? There's network vendors, maybe system vendors. So quite a few people. Please keep your hands up. Who feel that they get the most out of these contracts? Like get their money's worth. Well, I see where this is going, and I think Peter is going to help us with that. So Peter, please take it away.
Yeah. Is it on? Yeah, it's on. Welcome to how to get most of your support contracts. A little bit about me. I'm Peter Foppen. I'm technical solution architect at Comstor, which is a distributor of Cisco in the Netherlands. So I've experience working with Cisco partners from freelancers up all to the global gold partners in the Netherlands. I also am training instructor doing training sessions for Cisco partners. And I'm a bit of an aviation and space geek, so maybe you'll see some pictures of airplanes. Please note that I normally day-to-day work a lot with Cisco, so that's my point of view a bit. But most what I'm going to talk about can also be applied to other networking vendors. Maybe some different service level agreements, but for the most part it's the same. Okay, the basics. When you open a support case with Cisco TAC, you can choose from 4 severities. Ranging from 4 to 1. Severity 1 is a complete network shutdown. Severity 2 also. And Cisco will then engage with you 24/7 working on that case. It's also severity 1 case and 2 cases are also a little bit different in that first things first, and that's to get network traffic flowing again. So maybe do some workarounds, maybe reroute some traffic, and then do some root cause analysis. Severity 1 and 2 cases can only open by telephone, because when your house is on fire, you don't send an email to the fire department, you call them. So that's the basics. You can find it in the TAC resource guide somewhere, but nobody reads it. So, but if you're not happy with how your case is going, then you can call them and ask for the duty manager to explain, okay, this is why my case is not running well. This is my favorite. I call it the proactive support case. Sometimes you're working on some new technology. You've tested in the lab, but you're not really quite familiar with it. And you have a big important deployment over in the weekend during service window. What you can do is open a severity 4 case, so the lowest severity. And you put in all the relevant details. So serial numbers, contract numbers, the configuration you want to use, maybe a network diagram that can be useful, everything that is relevant for that case. And when you're working on the deployment and you hit any issues, you only have to call them and raise the severity to 2 or 1. But your case is already up and running, so that saves a lot of time. Often it happens that you're working on a case and then you have a complete mail thread of emails going back and forth, of have you tried this, have you tried that. Especially in some technical challenging environments, maybe it's best to ask for a Microsoft Teams or WebEx call or a Zoom call, because then you have 2 engineers, you can share your screen, you have 2 engineers watching at the same same issue, so you can speed things up, especially in communications. Please note that most support cases with Cisco TAC are not hardware related, but they have to do with configuration issues, bugs, software bugs. I don't know how to configure something, that kind of stuff. And if hardware fails, it's probably the power supply or some cabling issues of that kind of stuff. So when you buy new equipment, you have some options. You can buy a switch, and when that fails, you buy a new one. Then you maybe have some lead times, or maybe you have an old stack of switches and only one stack member fails, and then you have to replace the whole switch, whole stack of switches, because that single member is not available anymore. Then you can have, of course, buy 10 switches and then have the 11th number pre-configure it, put it on a shelf, and when one of the switches fails, you can put it off the shelves and replace it. Of course, you need to do the replacement, so during business hours that's not an issue, but out of sight of business hours could be an issue. And then we have support contracts. Please note that the first 2 examples only covered hardware replacement, but support contracts also mitigate the risk on configuration issues that you might have. And then, of course, we have the most expensive one, that is redundant hardware, redundant routers, redundant switches, and support contracts. With support contracts, you have, of course, several variants of service level agreements, 2-hour support, 2-hour hardware replacement, 4-hour next business day, depends on your networking vendor. Also on the install location. So, like 2 hours on the island of Texel by ferry boat, that's probably not going to happen. So, yeah, it finally comes down to cost of downtime. What does it cost? Maybe you have a factory that's 100,000 euros per day or per hour. Reputation for a bank, for example, or even human lives, as if it's in a hospital, for example. And cost of downtime can also change during the week or year. For instance, if you have a large retail environment with a lot of shops, during the holiday season, Christmas season, then they will make their money, and during the rest of the week of the year, then impact is a bit less. Okay, so when do you want to have a support contract? Does every access point and access switch needs a support contract? Of course not. You can make some smart decisions on that. Access switches in hospitals, impact is high, so yeah, probably you want to have that. Opinion of your networking vendor, of course, they want to have support contracts on everything. There are also some network devices in the network, I call them smart network devices or configuration heavy. We've seen that most support cases are on support on configuration issues. So these things like wireless LAN controllers, AAA service, firewalls also have a lot of configuration. So yeah, you can use that to mitigate your configuration questions. So this is the final slide. Some personality traits of engineers. We engineers, we like to solve things. We take great pride in that. We can spend days, nights, evenings on troubleshooting things. But sometimes that can hold back the business. So maybe your colleagues or your customers of customers. So please make wise decisions on that. Just ask a colleague, open a support case, have some means to get yourself further and not keep sticking in the troubleshooting phase. So that's on my presentation. And now it's time to open up for Q&A.
Thank you very much, Peter, and I see that Teun is quite.
Yeah, hi. Not so much a question, but more as a remark. I agree with the do a call or a web, a Zoom, whatever. However, I would recommend, if the vendor doesn't do it, make a summary of it. Make sure you have like a written down what happened, what you discussed, what you tested, what you observed, because you can see a lot in an hour of Zoom sessions and you forget. And also you can read that back and show it to another engineer you're talking with. So I would always recommend make notes. And some techs actually do that very well, some don't. So,
yeah,
that's one
certainly
takeaway.
Yeah.
Okay, well, who does a contract with like people who have big support contract at Cisco? And I was wondering, what would you do whenever your vendor does not honor the contract you paid for? I had like a specific case recently where this customer had 5596 that were still on support contract. Those things are old as hell. And they died. And they died like within 4 months, all of them. And there were 4 devices. And that was not, well, Cisco could not provide the devices and so on. So what do you do in those cases? What's your thinking?
That's
ask the legal department to deal with that.
Good question. That's a good question. At least talk to the escalation to the duty manager. Maybe that customer has an account manager within Cisco to talk to them and escalate it in that way. Even go through higher management. If that does not work, then yeah, eventually it will become some legal issues, I guess.
Yeah. Okay, thank you.
Unfortunately.
All right, looking at our online moderators, do we have any questions from IRC or Discord? All right, and thank you again very much.
Oh, sorry.
Can I question?
I'm sorry. Please go ahead.
Rinse Kloek, speaking for myself. Do you happen to know if there was a case like, for example, you had an issue with a Cisco router or something, or a Juniper, and you did a lot of debugging, spent a lot of time, and you discovered it was a bug on the Cisco Juniper side. Has it been the case that people sent an invoice to Cisco for that? For example, if you spent... yeah, I think it's reasonable. If you spent, for example, 100 hours fixing their problem, you pay them, and actually you need to pay extra hours to fix their problem. Do you know cases of that?
No. No, but I went with at least 5 times with Cisco, like 20 Cisco partners to Cisco TAC in Brussels. And we can talk to it later on during the break. But they do also have third-party vendors in the TAC lab.
Third-party vendors?
Third-party vendors, not only Cisco.
Okay.
So they can do troubleshooting with third-party vendors, like Checkpoint, Juniper, whatever.
Yeah, okay. But you don't know a case of...
No.
Okay, thank you.
All right, thank you again, Peter. All right, next up we have our coffee break, which is downstairs. And we have that until 15:40 when our program resumes again. So please head downstairs for some coffee or tea or some other refreshments, and we'll see you right back. Okay, welcome back, everyone. I hope everybody got some nice refreshments or some coffee or tea. Maybe 2 cups, maybe 3, maybe 4. Please don't drink too much coffee. Then we have to call people, and it's a whole hassle. So we're not done with BMP. Next to me, I have Thomas Holterbach, who is going to talk about expanding internet routing visibility with BMP. I'm very interested to see how I can use this for my own network and maybe at work. So please take it away.
Thank you for the introduction, and good afternoon, everyone. So today I'm going to talk about BGP, BGP monitoring, and BMP. So you probably all know this BGP monitoring tool. It's the NLNOG looking glass, and perhaps you are using it on a daily basis. It's useful to verify that the routes to your prefixes, they are good. And these BGP monitoring tools, they are possible because network operators, they are willing to share their routes. So there are many other monitoring tools like that. And historically, there are 2 main BGP data collection platforms. It's Rypris and RoadViews. And each of these platforms, they collect data from about 1,500 BGP routers that we also call vantage points. And then they store the data and they share it with the community so we can build these monitoring tools and we can also do research. At the University of Strasbourg in France, we decided to build our own BGP route collection platform, and it's called BGP Routes.io. So it's a new platform because we just launched it a few months ago. And the main difference between BGP Routes.io and RIS and RoadViews is that we try to prioritize coverage, so the percentage of ASCs that share the data, whereas RIS and RoadViews, they tend more to prioritize data retention, so they want to keep the data forever, and this is very useful, for instance, for researchers, even if that means maybe not pairing with some routers because that would just make too much data to store. We also say it's a next generation BGP route collection platform for different reasons. One of them is because we don't just have our own peers, it's because we also take all data that is publicly available and we aggregate all this data into one single repository. So there are other reasons why we say it's a next-gen platform, but today I don't have the time to go into those details because it's not the goal of this presentation. So if you're interested, you can just watch our NLNOG 94 presentation. But for now, I have to move to the actual content of this presentation, which will be about more like BMP. So that's the outline of this presentation. So first, I will show you why when we operate a BGP data collection platform, it's hard to increase coverage. And then I will explain you why BMP can help here. And then I will show you that if you're interested, you can connect with BMP to BGP Routes.io. You can monitor your session, and you can also use the data if you want. So let's start with why increasing coverage is hard. So the first challenge is to actually motivate network operators to peer and to share the data. And today, the BGP monitoring tool that exists, they seem to work fine. So there is no direct incentives for operators to continue peering and sharing more data. And the problem is that today, if you look at recent RoadViews, they only peer with about 1% of the autonomous system. That's not a very high number. And besides, this number has not increased over the last 2 decades. So they are only getting data for about 1% of the autonomous system for more than 2 decades now. For BGP Routes.io, in 1 year, we could get about 40 peers. It's good, but we need many, many more peers if we want to get accurate BGP monitoring tools. So even when we convince an operator to share the data, there is another problem, is that what happens is that that operator will set up a BGP session with the platform, and BGP typically hides routes. So we won't see all the routes that that operator could actually share. And here I want to illustrate the problem. So imagine you have a BGP router here in gray, and that BGP router pairs with some ASCs, here 3 ASCs, so AS1, AS2, and AS3. So that routers receives BGP route updates from these autonomous systems. These BGP route updates, they are arriving, and first they might be filtered or denied by those inbound filters. The updates that are permitted, they then go through the decision process, and then the RIB is calculated. And finally, the best paths, they are announced to the peers if they are not filtered by the outbound filters. So that's really like the typical BGP processing pipeline in a BGP router. And now if we imagine that this BGP router peers with a data collection platform like BGP routes.io, like RIS or RoadViews, well, we will see the best and non-filtered path. That is great. However, we will miss all the routes that are denied by the filters, and we will also not see the backup path. And this is really a pity, because the operator agrees to share this data. It's just that this data is not sent over the BGP session. BGP AtPass could help, because in fact it can announce backup path. The problem, though, is that, first of all, BGP AtPass does not announce the routes that are denied. And besides, with BGP AtPass, even if we see the backup route, it's hard to know from where the backup routes they are actually coming, from which peers they are coming. And when we use data to make analysis or to do research, we need to know where the data come from. We need to have accurate and precise data. And so this is why BGP AtPass can help, but it's not really the fundamental solution to this problem. And this is now why I want to introduce BMP and explain why here it can be the solution. So BMP has two main advantages over BGP when used for monitoring. So first of all, it provides all route updates on a per peer basis. So we really know from which peer the routes come from. Second, it also provides updates at possibly all stages in the BGP processing pipeline. So basically, it gives us a lot of flexibility over what we want to share, and we can also export and decide with a very fine granularity what sort of data we want to export. And this is very useful in this case. And on top of this, it's also very simple to configure. It's just a few lines of configuration in your router. So when we take our previous example here, so there are a total of 5 stages in a BGP router. So the first stage is on the left here. It's just when all the routes, they arrive before they are filtered. Then there is a second stage just after the inbound filters. Then there is a first stage, which is called local RIB. This is like the best path in the RIB. And finally, there are 2 other stages, before and after the outbound filters on the right here. So if that BGP router has a BMP session with a data collection platform, we can really decide which data we want to send, and at any of these stages here that I have shown. In the context of BGP routes.io, what we recommend to do is to export the Outage in pre-stage only. So this is the stage on the left here. Why we recommend to do this? Because this is just the stage where we see all the data before they are filtered. So we will see all the routes. So that's the best for us. Besides, if you just do this, users will also not be able to infer your routing policies. And that's probably something you also would like. Because in fact, if you also share, for instance, the local RIB, then we can infer which routes you are denying perhaps that's not something you want to do. But our infrastructure supports any stage. You can even send multiple stages, it's fine, but we just recommend sending data for that stage. So now, imagine you do this, what happens here? So now instead of having just one vantage point, if you had a BGP session, now with this BMP session, it's like if we had 3 vantage points, because in fact, we really see the routes that are coming from IS1, IS2, and IS3. So it's like if we had 3 BGP sessions with IS1, IS2, and IS3, but instead of 3 BGP sessions, we have just 1 BMP session. So it's less effort for operators, more data for users, and this is why BMP here can help. Okay, so now if you are convinced that BMP can help, I will show you how you can connect to BGP routes.io with BMP. Well, it's actually simple because we have automated everything. You can just go on the website. You then just have to log in and you can authenticate using your peering DB account. And then you just press on the Start Peering with Us button. And then you will end up in a page where there is a very simple form that you need to fill. Basically, just give us your IP address, your SN, and you can also say if you don't want us to store and share data for some of your peers. We are doing this because sometimes with BMP, I mean, for some routers, you cannot say for which peers you want to export the data. It's either you export data for all peers or none of them. So here, at least, we give you some flexibility for that. Okay, so once you have submitted that form, you just have to configure BMP on your router. It's very simple. We even provide examples to help you, but it's just a few lines of configuration. Okay, so once you have set up the BMP session, you can monitor it. So you just click on the Your VP button on the top right corner here, and you arrive on this page. And this is, for instance, what you would see if you are RGNet. RGNet is the network operated by Randy Bush, and he agreed to use his example here in this presentation. So Randy has a few BGP sessions with us, but today we don't really care about the BGP sessions. We care more about the BMP sessions at the bottom. So he has 2 BMP sessions with us. And when we look at the details here, we see, for instance, in this column, the number of vantage points that are derived from these BMP sessions. And for instance, in the second BMP sessions here, you see that we are actually getting like 10 vantage points. So we are getting the data from 10 peers, but from only 1 BMP session. And this is great. So that's typically what you would see also if you start to connect with BGP routes.io. Okay, so now if you want, you can also use the data. You can use the data because all the data we collect is publicly available. We make it publicly available because we want it to power the next generation of BGP monitoring tools. And for that, we have 3 ways you can access the data. So first, there is an MRT archive. That's a very standard way to access the data. We also have an API. That's rather unique. And finally, you have a WebSocket stream if you want also to get the data in real time. So depending on the use cases, you may want to use one way or another. But just for this we also have Python interfaces to simplify your life if you want to use the data. So you can just use our Python library. And now I'm just going to illustrate you how you can use the API, for instance. And what we try to do here is we want to make things transparent for the user. So the user doesn't really care if the data is collected from a BGP or a BMP session because it's in the end, it's just going to be route updates. So that's what we try to do here with the API. So everything is transparent. There are just 4 endpoints, vantage points. So you use it, for instance, to get the vantage points you want. So you first call these vantage points, and then you take the input and you give it, you take the output and you give it as input to the other endpoints like updates, RIB, and topology, depending on what you want to do. So this is just a quick example. So imagine you want to build a looking glass, for instance, like the NLNOG looking glass. Well, first of all, you would just have to import the PyBGP routes API. And then you just call the vantage points function, and you specify which vantage points you want to take. So for instance, you want to take all the vantage points from bgproutes.io, from RIS, and from PCH. And then you just put these vantage points as input to the rib function. You also specify a date and also some prefixes. And then you will get the answer in a few seconds. And here you don't really need to care if the vantage points they are from a BGP sessions or from a BMP sessions. It's all transparent. Now, if you care about that, there is a parameter peering protocol, and you can say you just want the vantage points that are derived from a BMP session. But in practice, you don't really need that. Unless you really want to measure something about BMP, you probably don't need that parameter. Okay, so that concludes my presentation. So this is just a quick table that summarizes the pros and cons of BMP versus BGP when used for monitoring. If you're interested, of course, you can peer with us. Now I'm happy to take your questions, and we're also happy to take any feedback, any positive but also negative feedback, because we are really in the process of implementing this platform. So any also comment or things you don't like, we would like to hear it so we can improve the platform even more. Thank you.
Thank you very much. And I see we have one question. Robert.
Wow, this mic is high. Katja is asking on IRC, have you thought about saving historical data by uploading it to the Internet Archive?
So storing historical data. So we are already storing data we collect, so historical data, either in the MRT archive or in the API as well. You can query data like past data. It's not just like real time. So if you want data for the last few days or whatever, you can also use the API. For now, the API, we only keep data for 7 days because it consumes some hardware resources on our servers. But soon we will be able to support like multiple months of data. It's just that this is a research project, so we have like a tiny funding. But like we have spending a lot of time to make optimizations in our database. So sooner or later we will be able to support like multiple months of data. So that's yeah.
Hey, my name is Victor. I'm from Booking.com. I'm curious, if it's not a secret, what do you use as a collector for a BMP?
If you mean internally or?
Yes.
Yeah, of course you could use. So now it's not the main use case, but
no, I mean in your case, what do you use to collect BMP data?
Yeah, we use our own code. So in fact, we could have used Rotonda, for instance, who was presented right before. But in our case, we wanted to something that is custom to just what we need, especially in terms of scalability. I'm not saying that Rotonda doesn't scale. I'm just saying that Rotonda is a very generic tools, whereas we try to build a tool that is very specific to exactly what we want to do. So we have a small C code that just gets the data either from BMP or from BGP, and it just does what it needs to do so we can scale and we can get data from thousands of routers.
Okay, thank you.
Yeah.
Thanks again. I already have a BGP session set up, so I should also set up some BMP sessions as well.
Yes.
Thanks again. All right, and that brings us to the last talk of today. It's, went by quite quick, if you ask me. But then again, I keep myself busy during these days as a board member. For the last talk, I hope the production team has a sensor bleep for me while I introduce the title of this talk, which is the no bullshit. I didn't hear a beep. And let me say this correctly, the no bullshit way to build infrastructure that lasts. Tony, the floor is yours.
No apologies necessary. So that answers my first question. I'm not allowed to swear. Damn. Anyway, so let's kick straight off. My name is Tony O'Sullivan. I am the CEO of Reton. First of all, a disclaimer and a confession. I am not an engineer. And for that, I apologize. This will be the least technical conversation you will have today. However, hopefully, it might give you some insight as to how to have discussions with your commercial and your financial colleagues about how to get some of your network projects approved and the arguments you might use. Second of all, a disclaimer. What I'm going to go into in this presentation, no network is perfect, including Reton's. There's no such thing as 100% uptime. We should all be adult enough to be aware of this, and the presentation will go into some of the issues that we've had, as well as some of the issues that other networks have had as well. And lastly, a little bit about Reton. And this is not meant as an advertorial, it's just meant as a way to explain the perspective from which I'm coming to this presentation in. And that is that we run a fiber network and a DWDM network all the way from London across the border with China. And across that network, we run one of Eurasia's largest IP/MPLS networks. And we extend that network across Southeast Asia using leased capacity. And what that means is that our IP/MPLS team are customers of our infrastructure team, and of course we are customers of other people's infrastructure. So we see this very much both from a supplier and also a customer perspective. Lastly, the title. Hardwired for chaos is the way our marketing team decided to put this in NLNOG. And it's a really interesting turn of phrase, because why would you hardwire anything for chaos? But unfortunately, that is the nature of what we're doing today. Our infrastructure is hardwired, and the world is chaotic, so we need to figure out a way to make that infrastructure work for the networks of today. So, first, I'm guessing our marketing team owe a little bit of a propos to Cory Doctorow. It's not inshittification in this way, it's deshittification. And there are 6 stages to this. The first of all is identifying you've got a problem. And there are some problems, and we're going to use some really good examples of those later on. The second of them is to discuss your thinking and our thinking about how to approach this problem. If you don't have a philosophy which drives you and drives the way you think about your network design, you're quickly going to come unstuck. Then we're going to share some real-world examples using leased infrastructure, a combination of leased and owned, and then totally owned to show how we've overcome some of these problems, and in some cases, how we didn't, and how things went truly wrong. And then we're going to have a little bit of a call to action about the things we can change inside the industry. So those of you that can read, and those of you that know your geography will know that that is a map of Taiwan. Why am I using Taiwan? So we're going to come to a real-world example later on a bit. But ultimately, Taiwan encapsulates many of the problems that we see in internet infrastructure today, but in one easy-to-identify, hugely problematic network issue. So first of all, it's an island. Its only real wholesale connectivity to the internet is via subsea cables. There are a limited number of them. They use a limited number of CLSs. There's only 3 main CLSs. It has a fake dual carrier hotel system. And by that I mean you get people who go, yes, we are diverse. We are in A and B. And you're like, well done. That means you're in the same building with the same power supply, just on different blocks. It's not really diversity. And then, of course, you've got the local carriers who do not exchange that much traffic locally, which completely exacerbates the problems which come later on. Last of all, you get to the problem which I demonstrate here, which is poor marketing maps. I'm glad our head of marketing has already left. But ultimately, look, you can't display full technical information on a marketing map, but for some reason, often customers and potential partners take them as reality. Clearly, all of our cables do just not fly into Taipei. They use multiple CLSs, and unless you don't decide to dig deep and ask the right questions, you will not discover this. So let's cover a little bit about resilience and what we mean in terms of your network. I feel like I've gone too fast. So first of all, let's think about your philosophy. What do we mean when we talk about a resilience-first philosophy? We have a rule inside this business. You can ask any of my colleagues. It's rule number 1 inside the business for every department, which is to think of your customer. If you think of your customer first, you will build your network as though it was for yourself. And what does that mean for me personally? That means if I had to take a phone call from a customer to justify why something had gone out, would I feel warranted in my answer? Yes, we built it as best as possibly could be imagined, given what we're actually doing. And just to highlight this, I'm probably the last CEO of an NSP our size that is top of the technical escalation chain. If you buy a service from us, I'm sitting at the top of it. So at the moment, I am fielding a lot of calls from Taiwanese customers, as we'll come to in a second. So let's deal with the basics. I know I'm talking to a technical crowd here, so some of this might be a bit too simple for you, but I feel like sometimes people forget. Yes, you will need multiple paths into a particular location. The minimum is 3. If you're on subsea these days, I would say it's minimum of 3 in each direction, total 5. It has got that bad in some regions. Those paths need to be truly diverse as much as possible, as much physical diversity as you can get. You need diversity of suppliers, as we've just seen with one of the major suppliers of terrestrial connectivity in Europe. It can be a single hacking attack which can take that supplier totally offline. If that's your single supplier for a location, you are stuck. As you get more into the detail, you need to start thinking more carefully about, are your redundant routes capacity matched? If they're not, can you scale them quickly? And this needs to then come into your technology stack, and how quickly can you move forward with this? You also need to think about who are the suppliers. And I don't mean this in the sense of I prefer brand A to brand B, but I mean in the sense of if there is a problem, are they able to force other rescue missions to save you? And I'll come up with an example of that in a little bit. And then lastly, the big one that we've seen over the last 4 years is about diversifying your geographical risk. And I mean this on both a macro and a micro level. On the micro level, of course, that means keeping your physical paths separate, but on the macro level, it means understanding which regions you're traveling through and the issues that might be presented, and the Red Sea is a fantastic example of this. Then lastly, we get into the operations and processes which are underpinning your infrastructure. Do you control your own engineering teams? Are you able to get them deployed in the field in an emergency? Do you control your own spares and your own supplies? Or are you dependent upon a vendor's SLA, which might come to nothing when it comes to a particular region or country? And then, of course, we get to the layer 3 level. If we're talking about layer 3 services, and this is a big point of contention which I frequently get questions on at peering forums, which is about our requirement in our peering policy for geographical diversity for those people that wish to peer with us. If I have a major peer, I want that geographical diversity. I do not want to have network risk coming from somebody else's network. So let's deal with some real-world examples. And we covered this one, which is Taiwan. Now, back before 2024, we had 4 subsea systems into Taiwan, and we were sure that was sufficient. We looked at the history, we looked at everything that had gone on, convinced. And then in 2024, there was simultaneous multiple outages. Now, they didn't impact us too much. They did impact us, but we managed to stay up and running. We managed to continue with all of our committed throughput. We managed to maintain our latency performance for our customers, but we got lucky. And so we decided we needed 5, and we thought that would be sufficient until this year. And very honestly, when I created this presentation with our marketing team a couple of weeks ago, the situation is different to how it is today, and it's got worse. So to my Taiwanese customers, if you're watching, I'm sorry. It's not quite as good as it should be. So this year, we've been in a situation where we've had 4 concurrent subsea fiber cuts around Taiwan, 3 of them impacting Retin's network. We weren't actually on one of the systems. One of those fiber cuts took 212 days to repair. Now think about that in terms of a network outage, 212 days. We are today in a position where all three of our cable systems, which point towards Hong Kong and therefore point towards Europe, which is the core of our network, are down. So we're in a situation where now our customers in Taiwan are experiencing increased latency. Throughput is still just about covering the committed requirements we have for our clients, but obviously people cannot burst and they cannot utilize the network as much as they would like to. This is compounded by the fact that within Taiwan itself you have another issue, which is that the vast majority of the cable systems, the backhaul is provided by the local incumbent. And of course, many of the cable systems, the consortium member is the local incumbent. And of course, that means they are maintaining their price base. This, in turn, means that we end up with a pricing disparity on subsea, which pushes all of the major international providers onto one or two cheaper cable systems. And of course, what that ends up with is when there's a major outage on those one or two cable systems, we are where we are today. And where we are today, a few months ago now, we had a situation where one tier one had gone completely dark, where another tier one was scrabbling around the market looking for half a terabit of capacity on a working cable system very, very quickly. And of course, we're in a position where we can't facilitate all of the burst requirements of our customers. And part of that comes down to the fact that those customers, of course, were depending on 2 or 3 carriers thinking, well, no one's going to go totally down. Appears it was wrong. So what worked in our network design? Well, we're still functioning. We're still managing to provide what we committed to for our clients. What didn't work? Clearly, latency. Clearly, throughput. What did we learn from this? This is an interesting one because I'm going to make a slightly contentious proposition, which is that actually buying some capacity from the incumbent at higher price levels on their consortium cable systems is actually beneficial. And the reason for this is quite simple. When you actually look at the repair times, as I mentioned before, one of those cable systems took 212 days to repair. It turns out a state-owned incumbent is pretty quick at repairing cables when the government is on their back. Just saying. And when we first came into this network design, I was of the opinion that quantity isn't everything, but clearly quantity is something. So what else did we learn? We learned we probably need a 6th and possibly a 7th cable system out of Taiwan specifically. And as I mentioned before, Taiwan is a very exceptional case. It's in a unique geopolitical environment. It's in a unique environmental environment. It has issues with huge amounts of shipping. It has issues with tectonic activity, with volcanic activity, typhoons, just about everything you can imagine. It's a really complex case. But this just goes to show where we've reached. Let's talk about the Red Sea a little bit. So obviously there's been multiple news articles about this, but for us it was a slightly unique scenario. For those of you that do not know, we have a terrestrial cable system which covers Central Asia and connects Europe to Asia. And when we first launched this cable system, obviously we configured a couple of 100 gigs of capacity, and we had maybe 20 to 30 gig of VPN and capacity customers running on this network. And we thought, we've got some spare network, what do we do with it? And so we allowed our IP MPLS team to run the IP network across it. Now, many of our competitors who also have terrestrial infrastructure thought we were crazy. Price per megabit, which is 3 to 4 times that of subsea. But our customers got used to it. And we thought about it slightly differently. We thought about it from the perspective of your cost of failure. What happens if your network goes down? What happens if your network performance starts to suffer? And it turns out we were right. When it came to 2024, obviously I think most of us are aware, we were in a situation where in the Red Sea, AAE1 went down, the BBG-EIG combination went down, and then of course SeaMWE5 had its cable cut in the Indian Ocean. Now those were the 3 100 gig native cable systems between Singapore and Europe. So you're in a position where essentially most of the Europe-Asia transit capacity has gone offline. For our competitors and for other people in the industry, this meant traffic going around the US to Europe. It meant, in one case, going via Australia to the US and Europe. And frankly, not very good performance. For us, it meant capacity going back to Hong Kong, transiting China on lease capacity, and then reaching our network in Kazakhstan, and then heading back to Europe. So we ended up with a situation where most of our customers were seeing typically between a 5 and 15 millisecond latency increase for European connectivity. So what worked? Well, I mentioned before about scalability. When it comes to scaling up our Kazakhstan network and our Central Asian network, dead easy. We run the DWDM platform, fully Infinera-based, spin up a few licenses, configure some channels, no problems. But we did have a bit of a weak link, which was China, and then for Singapore as well, the connectivity, subsea connectivity between Hong Kong and Singapore. We managed to solve the Chinese part because, of course, we have some leverage with the Chinese carriers. They also desperately needed capacity back to Europe, so they were willing to work as quickly as we were. Unfortunately, Singapore to Hong Kong is a relatively competitive open route where there is a significant amount of capacity available. So this should be a lesson to all of us about understanding what is the market like, and if you can't scale quickly, you might have to overbuild slightly and just suck it up. Now, of course, that was 2024. We are now in 2025, and we're back to the Red Sea again. For those of you that saw a couple of weeks ago, there are now, I think, 4 cable systems which have been cut off the coast of Jeddah. We're not involved in Saudi Arabia, but I am 100% sure there are some Saudi networks which are going, I wish I bought capacity on Amir and Amir 2, which takes the terrestrial route north and out towards Israel and out via Iraq towards Turkey. Because at the moment, that is another complete disaster which has come about from this. And then lastly, we have our example which is based purely on our own infrastructure. And actually, this one is, for my view, a slightly more interesting case because it touches not just on the network design, which is actually relatively simple and relatively obvious, but actually about your operational capabilities. Now, for those of you, I'm 100% sure you all know about the war. I'm not sure that all of you know about the way that the Ukrainian internet was configured before the war. So before the war, a large amount of Ukrainian internet traffic actually routed via Russia. Obviously, there are multiple cable systems heading into Russia. A lot of Ukrainian people were consuming Russian language content. It kind of made sense. Obviously, the moment the war hit, most of those fibers on the border were cut, whether intentionally through wanting to disrupt communications or trenching on the border to try and defend against the Russian invasion. But essentially, those connections were cut. And of course, even if they weren't, you don't want to be routing Ukrainian internet traffic via Russia. This created a bit of a problem for everyone, including us, because we only had 2.5 fiber routes exiting towards Europe. And I say 2.5 because we had 2 from Kiev back towards the border and then 3 from the border onwards. But essentially, it's 2.5. And we had a bit of lease capacity in the south, which helped to alleviate some of it. So as you can imagine, the Ukrainian internet had a few issues. Now, obviously, the war created particular problems. You end up with fiber cuts, lots of them, whether it's trenching, whether it's artillery strikes, whether it's missiles. You have numerous issues with equipment being blown up. It turns out the best place for an ILA is not the bottom of a TV mast. Apparently, they are targets. So we lost more Infinera amplifiers than I care to think about over the course of that. It does really create quite a few problems. And of course, you have rolling power outages as well. So how do we get through it? So it's a multitude of issues. Yes, the network design held up. We've always had this concept about multiple routes, multiple levels of redundancy built in there, and it held up to a degree. But after a couple of weeks of war, it starts to struggle, especially when you're in a situation where you cannot necessarily get your engineers out to site to either fix fiber or alternatively deploy new equipment. So then it comes down to what relationships have you built up in the industry? And this is one of the most significant parts, because if it were not for the engineers from Atracom, who are the major fiber provider in Ukraine, and their willingness to go out into the field at any opportunity and repair fiber while sitting in shell craters, we probably wouldn't have got through it. If it weren't for the fact that we had some capacity swap arrangements with other carriers inside Ukraine where we all came together and shared our networks to ensure that everybody stayed up, we probably wouldn't have got through it. As it happens, we were in a situation where no IP POP went offline for any significant amount of time, which, given what the situation was, it's quite incredible. The survival of the network came down to a few key things, though. Part of it is people. We've always been really clear that you should empower your local teams, and we have a significant local team in Ukraine, to get on and make decisions for themselves. It meant they didn't need communication from us. Second of all, we maintain our own spares supply. This meant we weren't worried about having to ship in Infinera amplifiers or additional routers from outside Ukraine. We already had them locally, which meant we weren't reliant upon vendors. And this is what I was getting at before. If you're reliant upon a vendor for all of your equipment supply, you may have a bit of a problem in this kind of situation. The other part is investing in your team and making sure they know that you've got their back. The number of people that we speak to sometimes, and you say, why hasn't this been fixed on your network? And it's, oh, I'm waiting for so-and-so. And it's a third-party operator, a third-party supplier of network services, who's waiting for their contractors to go down there and fix stuff. In our case, our team report to us, and they were fantastic. This is how we got through it. One other thing which is really important, maintenance schedules. May sound like something a little bit meaningless, but ultimately, it's the only reason why our ILAs stayed up so long. We have a rigorous maintenance schedule. Every 12 months, we replace all of the batteries in our ILA. We were debating whether to do it in December 2021. Our local MD insisted. We followed her advice. All of the batteries were replaced over the course of January. And that's what kept our ILAs running for 72 hours on battery power. Had we not done that, the network would have gone down much, much sooner. It's amazing how the basics make such difference. So let's talk a little bit about some of the rules that we have when it comes to building your network. Number one, build for your risk. It is not a case of if, it is a case of when. If you cannot stomach the if you don't think you can handle that phone call from a customer saying, hey, what the? Then accept that it's a matter of when and build for that risk. You need to analyze and identify them, whether it's governmental, whether it's geopolitical, whether it's purely geographic based upon where your fiber runs. Understand those risks and build your network accordingly. The second thing is to design smart, not big. And what I mean by this is you don't necessarily need all the routes in the world. But if you've identified your risks properly and you've built your network around those risks, you can design a smart network. Think also carefully about your technology platform. Does it allow you to scale quickly? Does it allow you to do stuff remotely? If it doesn't, you're going to have a problem. And lastly, optimize efficiency, which might sound like a bit of a strange one when we're talking about network resilience. But ultimately, if you start thinking long-term about your network design and about efficiency, it means less rebuilding of POPs, fewer situations where you end up with a network POP which is distributed across 7 different racks of 3 different floors of a data center with multiple different aspects of cabling. It means you can build further into that POP because you've got more power availability whenever you need to. It provides you with options. So always think about the efficiency in your network because what you've got today is suitable for today does not mean it will be suitable for 5 years' time. And 400G ZR optics are a great example of this, especially in terms of spares minimization as well, because it means that you can start to standardize your spares across the network. Four fixes to stop the bullshit. Sorry. I forgot I can't swear, can I? 4 fixes to stop the BS. This is partly for all of us. It's not just about vendors. It's not just about suppliers. So redefine the language. Resilience. What does it mean? It shouldn't just mean packets were passed. That's not resilience. It's about maintaining network performance. The second one, if it seems too good to be true, obviously, most Dutch people speak English really, really, really well. I'm not sure if you know this saying. If it seems too good to be true, it probably is. If something seems too cheap, it's probably under-designed. Simple. If you're out buying in the market, you should understand roughly what the market price is. If something's coming in considerably less, it's probably not a suitably engineered position. Demand transparency. This should come from all of us. As a vendor, we should be supplying it. If we're under NDA, there's no reason why we shouldn't be sharing any information with you about how our network is configured. It's really important. KMZ's routing information, this should be shared. In your organization, I would encourage you to get your colleagues to do likewise as well. And then lastly, educate and inform. We need to educate people, whether by forums such as this, whether by sharing our knowledge. It's really, really important. Next up, challenging industry bad habits. This is not the title I wanted for the slide. The title I wanted for the slide was the crap that customers sometimes ask us. The tier one fallacy. What do I mean by this? First of all, let's not try and get into the definition of what a tier one is. As far as I'm concerned, there is no such thing. Other people think there is, but it's all a load of nonsense. Ultimately, the tier one fallacy, if you are buying network infrastructure, tier one is about IP services. It's not about network infrastructure. If you're buying IP, a tier one can be fantastic in one geography and terrible in another. If you're on the level of buying IP, have they allowed you to test it? And if they have and you haven't, why haven't you done so? It seems absolutely crazy to me. If you've got the ability to test the product, go out and try it, because that's the way you'll find out the real information about your supplier's network. So it's a fallacy, this tier one part. The ownership illusion. There are many people out in the industry who offer DWDM solutions. Do they really control it? Do they really own it? Are they reliant upon the vendor for doing all of the installation, for doing all of the implementation, all of the maintenance? If so, are they going to be able to scale with your business? It doesn't mean they can't. It just means you need to be aware of this. The impossible promise. SLAs. SLAs are not guarantees. The number of people that come to us and they build their network on the background of SLAs, they say, I want a better SLA because that will protect me. It doesn't. It's rubbish. The SLA does not protect you. All the SLA is it's a way to financially compensate you for poor network performance. We'll come to it. That's all it is. It's financial compensation. Yeah. You need to build your network according to your understanding of what will really stay up. The SLA, it's nice to get the money back, but it's just financial compensation. And of course, half the time, it doesn't stand up. Subsea fiber cuts, force majeure, doesn't count. If you're one terrestrial supplier in Europe, I don't know if they're still doing it, but they used to claim terrestrial fiber cuts were force majeure. Which means, what other outages are you going to have? Equipment failures these days, equipment's pretty good. It's so rare, it essentially means your SLA is worthless. So the SLA doesn't protect you. And of course, anybody that's pretending they've got 100% SLA, you should probably walk away. Because it's a joke. There is one other one I'd like to put on this as well. And it's something I see. So inside the business, one of the few things I still control is the pricing. And the number of times I see this request, and every time it makes me laugh and then cry. Somebody will come and say, what would you do on price if I single-homed with you? And the answer is probably run a mile, because I probably don't want your business. But no, genuinely speaking, we would recommend everybody to be at least dual-homed. The only way you can be single-homed is when you get to a massive network service provider profile like Reton or like Hurricane Electric or someone like that, and where you have a distributed enough network that you can de-risk it for yourselves. So anybody that comes to me with that request, I'm sorry, you don't know what you're doing, and it's probably a different discussion. So what do we want from here? Substance over spin. which in its own right sounds like spin. But no, genuinely, let's build some proper networks. And when we talk about how we've built a proper network, let's share how we did it. Let's be transparent about it so that people can see you built a proper network. Design for disaster. Build properly, and when it inevitably breaks, rebuild it again, better, and understand again. It's not if, it's when. And then lastly, understand that failure has a cost. And honestly, this is your best argument with those people that hold your budgets when it comes to your network development plans and your general plans for your businesses. Yes, network costs money. And there is always going to be a trade-off between what you spend and what you bring in. But ultimately, failure can cost a lot more. It can cost you in terms of revenues. It can cost you in terms of reputation. It can cost you in terms of opportunity as well. And a great example of this being the Red Sea crisis I pointed to before. Because we had that terrestrial connectivity, we won a lot of customers who came to us and went, your network works. And we got a lot of burst traffic out of it as well. And of course, there can be a serious cost when it comes to a situation like war. So failure has a cost. Thank you very much.
Thank you so much, Tony. And I see we have a question.
Jesse from serverside.com. As some know, most subsea capacity providers continue billing when the subsea cable system is actually under maintenance or is down. So how do you deal with the financial pressure from having to deal with that and potentially having to buy capacity from other providers during that maintenance event?
This is a really good, difficult, and very present question in my mind. Because obviously we are in a situation where, the Taiwan example, which is ongoing as we speak, we are spending probably in the region of about $60,000 a month for subsea capacity that we can't use. Now, of course, if you've got a capacity customer on that, they are also in the same situation because that same force majeure clause applies. But obviously transit customers, you can't point to subsea outages and say, well, because it's not directly related, so you have to suck that up. That is built into the business model, and this is what I'm saying about how we think about what we've learned from this Taiwanese situation, that maybe our balance of cables from the incumbent compared to the third-party operators is not quite as optimal as it should be. And we probably need to buy more from the incumbent because when their cables break, they get fixed very, very quickly.
Right. Awesome. Thank you so much.
No
and what's your most expensive route? It's probably Japan to Los Angeles, or?
On subsea?
Yeah, on subsea.
Yes, probably on a per megabit basis. Yeah.
Nice. Thanks so much.
Will from AS2613. I was going to comment on your previous slide where it was to requote another company that says less BS, more engineering, and I think it really ringed a lot with this. And my question is, how do I explain to my customer, remember I'm an engineer, how do I explain to my customer that network resiliency as a cost when he's like, yeah, those guys are making that cheaper, I'll let him go?
Sometimes, yes, you do have to let them go. You have to let them go and learn from their own mistakes. It also depends upon, obviously, for you're a network engineer, it does depend upon your sales team as well, and how well they truly understand the networks they're selling. It varies from operator to operator. We're a little bit different than most in the sense that we don't have a pre-sales team. So we expect our sales team to truly understand it, but there is only so far you can go. If your customer's pure driver is price, that's probably not our business. From our perspective, it's a difficult problem that I've found myself in by virtue of my own propensity for telling the truth. But I got asked a question once where, what's your market positioning? Are you the low-cost provider? Are you the premium provider? And the answer is, fantastic product, okay price.
Good answer. Thank you very much.
All right. Do we have any online questions? No? Then thank you very much again, Tony. right. Now it's time for the merciless quiz. Has everyone prepared for this quiz? Well, if you look on the website, you might be able to find a PDF with some tips. Just go to NLNOG and click the events page. And that may or may not help you.
There might have been a few hints in the presentations.
Well, there you go.
A few.
I wish you all the best of luck.
So,
and take it away. The floor is yours.
So, hello. How are we doing today? Yeah, okay. So, who here hasn't had the NLNOG quiz before? Okay, a couple of hands. So it's going to be super easy. In a few moments, Peter's going to open up the app. You're going to see the website. You can scan a QR, I think. And then you're in the quiz. We have 20 questions.
Yes.
We'll ask them. You get 20 or 30 seconds to answer them. If you get it right and do it quick, you get more points. In the end, the person who has the most points wins. And I believe this year again, we'll do the first 5 people. And from top to bottom, so the number 1 gets to pick first. You don't win something if you're first, you just have to pick one of the prizes. And I'm going to have Teun explain what we will have.
So, what do we have? Well, obviously we have a Lego set. It's an excavator. Oh, yeah. Wow. Yeah. This is a really cool one.
Jawel, nee, dit is iets anders.
It's a fiber cutter, yes. Okay, what else do we have? We have a mini KVM toolkit. We have, what is the exact name? It's a BookNote Air, which is a e-ink tablet.
I think it's a color e-reader.
Yeah,
thing.
something like that. Yeah. We have, oh, this one is really cool. It's a bird feeder camera with AI and stuff like that. So you can actually recognize which bird is flying into the thing.
It can probably automatically count birds or something. Yeah. I don't know what makes it smart.
It has AI, and so it's cool.
It must be cool.
Actually, this is the first time we mentioned AI today, I think.
Yes.
Woo! Yeah, we had to do it. And last but not least, a mini workstation, an MS-01 from Minis Forum. So, yeah.
Very good.
Good luck, everyone.
Okay. Thank you.
Peter, you want this one?
I think Peter's just going to use that one. Okay, so. Hij moet naar de andere. Ja. Oh. Oh.
Iets kleiner maken. Scherm. Anders gaat het. Doe jij het eens. Alleen dit window.
Okay, here we go. Okay. So, either. Yes. Okay. Good. So there's a number on there. You can just go to Kahoot.it, punch in the number, or you can just scan the QR code. Can we get some music in here?
Sure.
Okay. Here we go. Nice. Yes. Very good. Very good. Very good. So those who haven't had the quiz before, there's a bunch of nerd questions, there's a bunch of more nerd questions, and there's some very hard nerd questions.
We also have fun questions.
Also fun questions, yes. And I think there's one popular culture question. So I hope you studied.
That one's also a nerd question.
Oh, I have no clue who it was about. But that's just
Maybe
me.
the old people will know.
Maybe. Okay, so if there is anybody who has a problem with getting into the game, please raise your hand, so maybe we can help you before we start. No hands, very good. Just give him like one more minute.
We have 184, so that's like 40 people left.
Yes. Also, if you're watching the stream, you probably have one, too much delay, and two, you cannot pick up the prize, so you're not eligible for a prize, even if you win. Which would be really good if you win.
If you're on the stream and you win, I will buy you a prize.
Here we go. So try it. Okay, 192. How many people do we have in the room? Do you know that? About this many?
Should be slightly over that.
Okay.
No trouble? No trouble anywhere? No? Okay.
All right, let's go.
Okay. I have to look over there to see my mouse.
Oh, wow.
Yeah.
Hey, there we go. Okay, so the quiz. Okay, question number one.
Go ahead.
What was Android, the operating system, designed for originally?
Originally.
Was it televisions, autonomous robots, photo cameras, or mobile phones?
Is that a robot on the photo? Or is it an Android?
Maybe it's both. Where's the music again?
Where's the what?
The fun music and the bleeps.
I don't know.
Oh, okay.
I got it from another website just now.
Okay, so it was photo cameras, and then Apple came out with the iPhone, and Google was like, shit, we need an operating system for a mobile phone. So they bought an operating system for a photo camera, and some Android developers have told me that that's the reason the operating system is really hard to work with.
All right.
All right, so some people were guessing, some people guessed really wrong, but
that's
well done. Let's see who got it right. Nice.
AI enjoyer. I know what you're picking. All right, question 2. Whose birthday is it today?
Ik hoor het geluid op de achtergrond.
You hear something? Ah.
There it is.
Right, so it is not the king. It is Marjoleijn's birthday.
Yeah.
Do we have any other birthdays in here? Your birthday as well?
Nice. Congratulations.
Your birthday? No?
No.
2? Okay, then I guess we're singing for 2 people.
Oh! We are going to sing without the microphone, just so you know.
I'm not going to sing at all.
Oh, here we go.
That's enough.
This was also a license-free version of the song.
Yes. We
so
take
we
care
have
in
no
these
problems
things.
on the stream.
I see almost everybody got that right.
Yeah.
Do you know when the king's birthday is?
Somewhere in April.
No, that's King's Day.
Yeah, that's his birthday.
It is not.
It is.
Is it now?
I think
it
is.
Oh, right. Yeah. Right. When it was Queen's Day, was
when
not
it was
the
Queen's Day, it was in January.
Previous one,
yes,
yeah.
Yes.
Got it.
You're so Dutch.
Yeah, exactly. Yeah. All
so
right.
let's see who was the fastest.
Oh.
Very
I have
close.
questions about the AI enjoyer. Question number 3.
How many bits of the IPv6 address does SNN-T pings allocate for caller information? Yes.
I carefully picked the word allocate to cover that. So width. But yes, SNT pings only uses 24 of those.
Hey,
32
very
bits.
good. Very good.
Nice work.
Very good. So people have been paying attention today.
Yes, I think
very
they
good.
have. I think they have. So where are we at?
Ooh.
Question number 4. What is the largest prime number that fits in a 9-bit unsigned integer?
We recalculated this 3 times, so we know the answer is correct. And let's see if you know which answer is correct.
Why not?
Know your binary numbers, man. Oh, folks.
That's a lot of 10 bits.
Yes.
Yes. No, the largest number that can fit in 9 bits is 511.
Yes, and 5.9 is a prime.
Yes.
Good job, yo. Ooh.
Oh, shit. So who is the AI enjoyer?
Maybe it's somebody at home who really wants it.
Question number 5.
How many tests were run by hand on internet.nl in 2024?
Caught you off guard there.
Yes. Got it, though.
There were several numbers on that slide.
Yes, yes. There were several numbers on that slide, but...
And 2 of them were identical. 2024.
Yes. Yes, very good. People
nice
have
done.
been paying
Nicely
attention. 8 million was indeed mentioned, but that was through the API, according to the
The
slide.
automated API test, yes.
Hands that by hand. Okay, let's see if AI Enjoyer is still going up. Oh! Very good.
All right. Question number 6. Oh, you do this one.
Which is not a cardinal gem?
I don't know. Peter helped with the questions this year.
Yes. It's, you can see it.
So what is a cardinal gem?
In the medieval times, it was mostly a thing. There were like 5 different kinds of gems that were special above all the others. Those were the cardinal gems. But topaz wasn't one of them.
Topaz was not one of them. Yeah.
No.
Okay.
I think the green one was emerald, and I forgot the last one.
Yeah. Yeah.
Anyway, a lot of people got this.
That's not a bad score.
No.
Or they just hadn't heard of topaz and went like that one.
Maybe, who knows?
Which is what I almost did.
I do enjoy that I picked the colors correctly.
You did not. They're randomized.
So I put them in this order in the fields.
Oh, okay. Okay, humans on top. All right.
Also, we have 5 people who got everything right up to now.
Yes.
And yes, very impressive.
Question number 7. Which CPU architecture is not supported by Linux kernel 6.16? I knew one of these, not the other.
Ooh, I hear some groaning.
Yes.
There are old people in the room.
Yeah, they were like, should have asked about 4.4.
Oh, that would have been even harder. Or like 2.6.42, which was the last one in 2.6.
Yeah. Didn't that end at 36? Okay, that is not bad.
No, it's not bad, but SunSpark is definitely still supported.
Yeah, yeah, yeah.
Somehow
even 32 bits.
Yes.
We don't know why. All right. Let's see. Oh, everything's changing.
Things are changing. Very good.
I don't think any of these people were in the top 5 before.
No. Yeah, except Joris. I think less.
Sorry?
Okay, next one. Oh, that's for me. Which pi is not real?
You might have to explain things.
Yes, I can explain. We'll do it after.
I'm seeing some irrational reactions.
Yes. Okay. So a Strawberry Pi doesn't exist. Orange Pi is a clone of the Raspberry Pi, and Pi the number is irrational, but it's part of the real numbers.
Thank you, Wikipedia.
Yes. You're very welcome. Oh.
Okay. Okay.
So only 2 people who are now in the top 5 got it right.
Yes. Yes.
Excellent.
Question number 9. When did the Dutch incumbent telecom operator execute Operatie Decibel, giving everybody a 10-digit phone number?
Yes.
I had one of those calculators.
We had
if
one as
anybody
well.
in school did not know I was a nerd yet, that was the week they figured out.
Yes. Also, maybe you just told them when it was because you were in school.
Yes, that too, yeah.
But yes, there might be people in the room who may have not been there. So
this can only mean one thing. NLNOG is getting young.
Yes. So who wasn't aware that this has happened? Good. All young people.
I do.
Yes, I also remember my old phone number. Very good. Let's see who got it right.
Well, that changes everything again. Almost everything.
It goes all the way.
Yeah.
Better than last year.
All right.
Okay,
Number
let's
10,
see.
halfway.
What was Spinoza's first name? The one that everybody knows.
The one they named a concert stage in Rotterdam after, because it's on the Spinoza-laan.
Yes. I found it out 1 week before I had to type in the questions for the quiz. That's why it's in here. Yeah. So he was called Baruch. For those who are from Rotterdam, it's a venue there on the Spinoza-laan. But he would also go by Benedictum because he was writing in Latin, of course. Oh, and he was a philosopher. Or ish. So, let's see who...
Halfway score.
Yeah.
Ooh. Oh, Paul, you're doing well.
But and Hendrik's coming up again, so
yes,
who knows
yes.
what's going on?
Come back, kid. 11. What was the primary occupation of Ronja Roovardotter's father? Leader of a robber group? Transit sales? A roving pirate? Or Fortinet sales?
I mean, it's all the same anyway.
No, pirates have boats.
Oh, yeah. Actually, all of them should be correct.
Like Pippi Longstocking's dad.
Yeah. Ah, that's true.
Looks like a lot of people confused this
Yeah.
with Pippi Longstocking. So that plan worked.
Very good.
Right, where we at?
Ooh.
That's a big lead, Paul.
Yeah.
Hate to see you lose it.
Is that a threat?
No,
Okay.
I promise.
The DHCP server from ISC reached EOL in 2022. When was the client EOL'd? We should have done specific dates. That's even worse.
They aren't really specific dates.
Oh.
There's like an email from June of that year saying we will stop later this year.
Oh.
And then there was no communication ever after. In 2021.
Oh.
Well, a lot of people thought it was this year.
Yeah, or the same year.
Yeah, probably because Debian is still shipping it.
Yeah.
And I think even Red Hat maybe. What? Sistron DHCP. When did that go end of life?
Oh.
Over 9,000, ladies
Very
and
good.
gentlemen and other people.
Okay.
13. Which of these options actually exist in GNU LS as packaged in Debian Strixie?
I got this one wrong. But that's also because LS has a lot of options. But also fewer than I think.
Somebody mentioned to me like a long time ago that almost all of the letters were covered. And it's over half of the alphabet in both upper and lowercase.
That's a lot.
That is not bad.
No, but it is all guesses.
Yes, that's mostly guesses.
Maybe next year we should do one for GCC.
GCC.
That also probably has the alphabet covered.
Yeah. It's something about seeing group names, I think.
Oh.
That's almost 10.
Yeah. What's the steepest slope a giraffe can traverse? And this one's actually backed up by science.
It's more than water and less than mountain goats, right?
Yes.
Yeah.
Give or take. Okay, let's see how many people guessed. Oh, okay, pretty good.
Not bad.
Yeah.
Not bad.
So it's actually 20 degrees, which is not a lot. Apparently, 45 degrees is about the maximum a human can do without help. But the problem with giraffes is because they can only do 20, there's a lot of problems with the conservation efforts because they can not move to other parts of the plane sometimes. Yeah, exactly. But yeah, 20 degrees slope, so that's not a lot. Ooh.
Not only did he break 10, he's almost at 11.
Yes, and he also has 6 in a row correct.
Yeah, I wonder what prize he's taking home.
Yeah, I don't know. We will figure that out.
Will we?
Maybe.
What is Terence Trent D'Arby's legal name?
I had no clue who this guy was.
Yes, you do.
I do?
You've heard songs.
Oh, maybe.
Okay.
Can you sing some of them?
I can sing none of them.
Good.
Or any song.
Nice guesswork, everybody.
Wow.
Nice guesswork. See, it was a hard question.
It was. Terence Trent Howard was his birth name, but he changed his name to have a new artist name at some point. That's some kind of rebirth. Yusuf Islam is the real name of Cat Stevens.
I knew that.
You knew that?
Yes.
Okay.
Okay, let's see who got that right.
Oh, Paul, obviously.
Nobody in the top 5 got this right.
I was like, is this thing on? It should animate.
I was confused.
All right.
All right. If I win today, this is the prize I will pick.
It's actually not easy.
No.
I know what my kids would want.
I think it's either the minis forum for me or the books.
Sorry, the
e-reader thing.
Right. Okay, yes,
Yes.
that is a good prize.
Yes, very good.
Sadly, you're all wrong. No, you're all right.
So it just came down who voted the fastest. Yeah.
Yes.
So some people got it.
Yeah. I think Paul might still be beatable, but it will be hard.
Yeah, but you have to beat him physically first. Because then he cannot answer any more questions.
No, I will fight you. 17.
How many delegations exist in the root-servers.net zone?
This is the hardest DNS question we have. Also the only one, I think.
Yes.
There's a convenient map of root servers on the screen.
Yes, very good.
In case you wanted to count points on a map instead of delegations.
Yes, especially the ones in the sea.
Yes.
Yes.
Oh.
So root-servers.net has no delegations.
It only has root servers.
Yes, it has a few A and quad A records, and that's about it.
But Peter, how many delegations are there in the root zone?
1439.
Yes.
Okay, this was the instinker of the day.
I do note that most votes went to 13, which is the number of servers in the root server zone.
Yes.
Yeah. That's a stupid question. People hate you.
Yeah, I know. That's fine. I can live with that.
Even Paul got it wrong.
Yeah. Oh.
18. What are the dimensions, diameter by height of a CR2032 battery?
I got this one right when I was testing the quiz.
Then yours must have been laying flat.
Well, yes, and I also had more time to think about it.
Yes. I hear people going 2 centimeters, no weight.
Ah, very good.
That is not bad.
That is very good. And it is indeed the size. Oh.
We have 2 more over 10K.
This is way more exciting than last year.
Yes, you should write the questions more often. Or at least some of them. Last before end.
What does awk and this thing do?
Should have gotten an AI to read that out.
Oh, yeah.
We have time. They don't.
That's true. This was another one of mine, so it's all my fault.
but I fact check it.
Good. Nice guesswork, everybody. Well done. No, it prints the first 10 lines of a file, so it just emulate head if you want.
Because it's like a selector that goes before the command. It's not a parameter to the command.
Indeed.
Yeah, okay. All right.
And NR just keeps increasing for every line that's being read.
Yeah, exactly. So you could also easily print like every even line.
Yes.
Cool.
With,
Final question.
With percent too, because it just takes
Yeah.
a modulo. Maybe that's
Right.
for next year. Hey.
Final question. You
Yes.
ready?
I am.
You ready? No? Good.
No? Okay.
Oh, wait. Scores.
Ooh.
So this might be our final list or not.
Yeah. Okay. Let's go. Oh, God, this one.
If A and B is 0, what mathematical operation is A or B equivalent to?
Those were too many words. Oh, this was his, by the way, not
This
mine.
just occurred to me. Well, wasn't even sure what I was doing. Programming, probably.
Yes, that's what you usually do. So I'm guessing we're going to have a nice split. Yes, very good. Can you please explain why this is?
Yes, if you have two numbers in binary, and for every bit position, only one of them has a 1, then OR is equal to addition for that row. And because there are no bit positions with 2 1s, there's no carry, so the OR is sufficient.
Okay. Well, thank you very much. Okay, so let's see.
Yes. Let's see. The podium. Number 3.
Foobar.
Mark.
Very good.
Coming up. Number 2. RW letters. Please come up. And I bet this will be Paul.
Hey, Paul. Very good. And can we also have the runners up on the stage?
Yeah, we'll find out soon.
Yeah, they were just on the display, but not anymore.
Oh, right.
All right. Do we?
No, they were not.
Summary, I guess. No. Podium again.
You can barely see what I'm doing. Oh, there. You actually see bigger letters than I do. Have you stopped sharing your screen? I have not. I'm sorry, it's an Apple touchpad.
And yeah.
Okay, there we go.
Cool.
That is our top 5. But where is our where or? Hello?
Hello.
You?
You?
Very good.
Very good. Come on over.
I was afraid I would have to buy somebody at home a prize.
Or you could have just picked one up here.
And then give it away?
Yeah.
You can do it as well. Okay. So, yeah, okay. So the first prize is for Paul. This is your second win, I think. Yeah. So, that's it. So the choice is yours. Will it be Lego again?
No, this time I'm not by car.
Do you need a ride?
Okay. Oh, congratulations. Number 2. How do I pronounce it? Okay. So, congratulations and pick your prize. Yeah. Yeah.
Yes.
Enjoy. And next one is Mark.
Mark, well done.
Foobar. Congratulations. I think this goes with it. Yeah, you need one. Okay.
Handig.
And next one, Eli. Is it? Woo! This is. So what will you be picking? The books. Okay, congratulations.
But who will feed the birds while you read?
Well, and Robin, that leaves you with... Yeah. Okay, so congratulations. So I expect some cool presentation next year where you will be explaining how you hacked this thing and hooked it up to some system. This brings us to the end of the, well...
Everybody, thank you for participating.
Yeah.
And,
Thank you.
Yeah.
Well done. Thank you. Okay, wait. Wait 1 second, because, of course, you two deserve a present as well. Thank you so much for presenting this again. So we're nearly at the end of, well, the more formal part of our event. Of course, we will continue with drinks and dinner and stuff like that. But before that, I want to thank a number of people. First, I want to thank all the presenters that were here today. I think we had a great program. I hope you enjoyed that. So thank you to those. I would also like to thank all the volunteers that helped us today and yesterday with the build-up, with filling the goodie bags, with, well, various things, scanning tickets, stuff like that. Thank you so much. We can't run an event like this without you, so thank you. And of course, I would like to thank Sven, Denise, and Lindsay, who are backstage, who are doing amazing work with the video streams, making sure we have cool recordings of everything. So thank you to them as well. And now the fun part begins, because we're going to mention them all again. Our amazing sponsors who made this possible free of charge. So here we go again. Nexpertise, KPN, Smart Optics, Arista, BIT, Amzix, i3D.net, Retten, Duocast, SpeedIX, LeaseWeb, Nokia, PowerDNS, Mini Networks, now I'm moving to the other side, Solid Optics, SpeakUp, Fusix Networks, NTT Data, LoneApp, Recorded Future, Correro, Kwanzaa, OpenBSD Amsterdam, 10IT, FiberRing, NLIX, Telesol, and your hosting. Thank you very, very, very much. Our next event will be the New Year's drink, which traditionally is in January. This year it will be on the 30th, and it will be in the Rechtbank again, in Utrecht. So we hope to see you all there. Before we go downstairs, there are a few things I'd like to ask. One, if you have any cans, cups, anything, any garbage, please deposit it. There's a trash bin over there. I'm not sure if there's one there, but please take everything with you. This includes your bags, all your personal belongings. This we're going to clean up here, and then it gets locked. So please don't leave your valuable stuff here. Take them downstairs. Yeah, and that is the end of the formal part of NLNOG Day 2025. Thank you all for joining us.